This call is now being recorded.
Hello everyone, welcome to all of you. Our resource person has joined. A very hearty welcome to our speaker, Dr. Dilip Sisodiya sir. We are delighted to have your presence in our STC. Thank you sir for providing us your valuable time in this STC. I am going to introduce about our resource person. Dr. Dilip Sisodiya is working as an associate professor and head of the department at Computer Science Engineering Department of NIT Raipur. He is working at NIT Raipur since August 2008. He also worked as a summer research fellow at Machine Intelligence Unit ISI Kolkata in India 2013 and adjunct faculty at DSPM International Institute of Information Technology near Raipur, India in 2018. He has over 20 years of academics and research experience in various engineering fields. Dr. Dilip Singh Sisodia contributed more than 100 referred articles, including 97 papers in Web of Science, Scopus Index Journal, conference proceedings, and book chapters, published by international publishers. He has included in the world ranking of top 2% researchers in 2022 through a study conducted by scientists from Stanford University, USA, in association with Elsevier BV. So far, his research work has been cited more than 1600 times, and each index and I-10 indexes are respectively 17 and 33. He shared his work at various international conferences by visiting Israel, Spain, Singapore, Thailand, etc. Dr. Sisodia successfully executed sponsored research and consultancy projects funded by SEES Coast and FIC Bengaluru. He has supervised 4 PhD theses and 8 MTech dissertations in the area of machine learning and currently supervising 6 more PhD in this area. He is serving as an active reviewer for many reputed scientific journals. He has also served in the technical program committee of various national and international conferences and board of studies of various technical universities. He has delivered more than 50 invited talks and lectures in conferences, workshops, short-term courses, and academic events organized by various institutes. He has organized many international and national conferences, FDP, STTTP, workshop, etc. for engineering faculty and research scholars. Dr. Sisodia is a senior faculty member of IEEE and ACM. He is serving as Executive Committee member of Chhattisgarh State Committee of Institution of Engineers, India since 2018. Dr. Sisodia also served as a head of the department CSNE NIT Raipur 2016 and 18. Executive Committee member of IEEE MP section 2020-21 and member chairman Computer Society of India Raipur 2016-17, vice chairman CSI Raipur 2014-16. Dr. Sisodia received a PhD degree in computer science and engineering from the National Institute of Technology Raipur, India. He earned his Master of Technology and Bachelor of Engineering degrees respectively in Information Technology with specialization in Artificial Intelligence and Computer Science and Engineering from the Rajiv Gandhi Technical University, Bhopal, India. His research interests include the application of machine learning, short computing techniques, artificial intelligence, biomedical signal, image processing. Welcome, sir. Please hand it over to you, sir.
Thank you, Dr. Dilip, for this generous introduction. And I also welcome all the participants who have joined this program, very important program from different institutes. Thank you, everyone. And I would like to start. So, just wait. It's visible? Hello?
Yes, sir. Yes,
Yes, sir.
Okay. So this short-term course on artificial intelligence and basically application of artificial intelligence and IoT in biomedical engineering. And the scope of my talk is I will introduce because title artificial intelligence is included. So I'll just brief about what is AI, and then we'll move to the machine learning. What are the different types of machine learning model, and discuss this Bayesian learning, Bayes classifier in detail. So this is the outline of this presentation. So first, without further ado, we'll start with this. Why do we need AI? Anybody? First, I would like to hear from participants. Any reason? Yes, please. Okay, no issue. So we'll take a simple example quickly, and which is very popular in computer science: traveling salesman problem. What is this problem? In traveling salesman problem, a salesman has to visit the number of cities, and she can start from any city, and he must finish it at the same city. And the salesman must visit each city only once. So if salesman is planning to visit a number of cities, then the number of possible routes are factorial n by 2. Means these are the different ways in the alternative ways by which he can travel to this set of cities. And here we look at this simple example. If we'll select the 10 city in traveling sales problem, then the 181,000 possible solutions are there. If we'll select 20 city, then number of possible solutions are the problem space will increase to 10 to the power 16, and if we'll select the 50 city, then it will increase to 10 to the power 62. And this phenomena where with the number of input, the problem space is exponentially grow, such type of phenomena is described as combinatorial explosion. So this is a one example, very classic example, how the problem space will increase with the input states or input numbers. So if we'll increase the number of n from 10 to 50, then how exponentially the problem will, this solution space will, number of states in solution space will increase. So such type of problem, if we'll adopt the conventional solutions, like if we'll use PFS, DFS for the possible solution, then it is very difficult for exhaustive method to solve such type of problem. So what is the alternative? The alternative lies in AI techniques. So this AI technique will solve, although their solution may be approximate or near about solution, it will not give a guarantee. Any AI solution will not guarantee it 100% optimum, but it will give you the it will not give a guarantee to the best solution, but it will give you optimum solution. So this artificial intelligence is like where we can apply the common sense reasoning. And this John McCarthy, who is also considered as a father of AI, John McCarthy defined AI is the science engineering of making intelligent machines, especially intelligent computer programs. So a computer program is also known as software algorithm that is able to do something or make decision that humans can do or make, but faster, cheaper, and with greater accuracy. So artificial intelligence solutions or AI based solutions or AI, nowadays AI is like computer science engineering, which was after before 5 to 10 years, as we see the computer science engineering similar. Now this AI is replaced. So AI is independent field where you can find BTech programs, MTech program, and like this many in sub branches you may find the specialization. So the objective of this as a whole AI, the objective of this AI subject is to develop such type of algorithms or computer programs which are which work as similar to the human being, but there are limitations. Human being mean like human brain. So what is the properties of human brain? There are human brain is very excellent in cognitive tasks like this computer vision, reasoning, logical reasoning, inference, or decision making. So is it possible, can we add these capabilities to a program or agent or software? Yes, we can do so. These tasks can be done in faster, cheaper, and with greater accuracy. So here in artificial intelligence, the intelligence, so intelligence is basically a property or ability attributed to the human being, such as to know, to think, to talk, to learn, understand, like this. So intelligence is knowledge plus ability to pursue, feel, comprehend, process, communicate, judge, learn. So these are many cognitive or sensory activities which are additional. So knowledge can be stored. Knowledge can be stored in program also. So there are different knowledge representation techniques, from simple predicate logic to conceptual dependency and this script, and there are many ways of representing the knowledge in computer also, in form of graph. Everything is available. So but we have to provide the ability to pursue, feel, comprehend, process, communicate. So intelligence is basically this, but artificial intelligence is how we can aid this ability to computer also. So artificial intelligence basically an interdisciplinary field aiming to develop technique and tools for solving problems that aid human beings are at good. Now the next, the different types, as I already share you that AI is a very large, or AI has itself has a huge scope, so it is very difficult to cover all aspects of AI. But we have to start with AI. So there are different techniques. This artificial narrow intelligence, artificial general intelligence, artificial super intelligence. So what we have achieved, this narrow intelligence. So already the work is going on. This ability to carry out a specific task like playing this for you may be heard about the deep blue, for this playing chess, get information based on the voice direction. This simple, not chat GPT, this simple like Siri, Alexa, such type of and there is spot, spam email, driverless car. So these are these specific tasks where we apply the artificial intelligence, and these specific tasks where we apply such type of AI is known as narrow intelligence. Then general intelligence. General intelligence means the human being will learn something, and human mind has ability to generalize on the basis of the learning, existing learning. So here the objective is to ability to carry out the different tasks that a human could do. Like recently you may be heard about these large language models, and the disruptive change is going on in this field. Large language model, from this chat GPT, this similarly Bard by Google, and there are many more, Bloomberg GPT, and there are many specific applications. In fact, government of India is also seriously thinking to integrate this such type of language model in the existing data, just to increase the efficiency. So such type of generalization is possible nowadays. Recently, last 2-3 years, we are able to achieve in many areas such type of generalization. So such type of solutions are known as general intelligence. And now the next field, which is not much work has been done, is known as super intelligence. And with the help of this quantum computing, this super intelligence applications we may see in near future. So these are the three different types of AI techniques. So sufficient work has already been done in narrow intelligence, and now the progress is going on in general intelligence, and also the resources or the base are going to prepare for this super intelligence applications. So the next, this is the, you can say, the artificial intelligence is a very, you can say, field in itself, and there are many branches of artificial intelligence like uh, robotics, computer vision, automated reasoning, natural language processing, knowledge representation techniques, and many more branches are there in artificial. So our artificial intelligence is the subject umbrella, and the learning is one aspect of AI techniques, and this learning is covered by a special branch of artificial intelligence where learning is required from the existing data, and this branch is known as machine learning. So there are many machine learning techniques, and out of this machine learning, there is a specific way of learning, like how human brain cells are connected, and what is their possible topology, and how these cells will interact with each other, and they are known as artificial neural networks. And these artificial neural networks can be trained with the help of some specific learning algorithms, which are known as deep learning algorithms. So everything is going to from this 1D CNN to these transformer models, attention models, these generative adversarial model gains, and there are many deep learning techniques are there, and these techniques are revolutionizing this artificial intelligence field. So artificial intelligence is a superset, then machine learning is a superset again, then this Venn diagram is clearly representing the relationship between AI, ML, and deep learning. The next technique, why this learning is so important. So first, what is this learning? So learning is any process by which a system improves our performance from experience. Like initially we don't we not able to write the alphabets. So what we'll do, we'll learn alphabet, how to pronounce them, how to write them. Many times we are failed to write a proper alphabet, and then we will do once again multiple times, we'll write it on notebook. So what we are doing, we are trying to improving our performance by doing again and again, and this process is known as, first we'll commit some mistake, then we'll learn from this mistake, then improve next, and gradually we'll do. So such type of process is known as learning. Again, this memorization is equal to learning? No, memorization is different. Memorization is uh, you can say very trivial task to remember, but we fail to generalize. So learning is like example of learning is infant babies learn his mother's face, or child learns about toys automatically. They every time they will see the face of his or her mother every day, and after some time they are able to recognize. So these are the examples of learning. So learning involves, what is the difference between memorization and learning? If you remember each and everything, we may not be generalized, but we learn something from the past experience, then we can get the ability to generalize the things. So this is learning. Then what is machine learning? So machine learning is basically, here again, building machines. That machines means these softwares sometimes may be supported by hardware. So building machines that automatically learn from experience. Now how experience will gather? So in case of this machine learning, this experience will be gathered in form of data, because this machine learning and this artificial intelligence was coined in around 1949, and the machine learning term was coined around 1956. So nowadays, why these techniques are getting popularity? Not earlier, because more than 50 years. So what was the problem? You can say the fuel for working of this AI or ML based technique is data. They cannot work without data, because for gaining the generalization ability, uh, we must have sufficient experience, or experience is in form of data. So earlier the data capturing was very difficult task. So nowadays the data is available. So data is not available, but data capturing is, we don't require some explicit way of capturing the data. Implicitly the data is stored. So data is cheap and abundant. Data is stored in form of data warehouses, data marts, data lakes, but still knowledge is expensive and scarce. Like we are visiting, we are discussing this uh, lecture with the help of this Google Meet. So we are generating the data, different attributes, different data set of we can take from here. So if we are visiting mall, or we are, whatever we are doing, ultimately we are contributing to the data. We are searching something, then we are generating the data. So nowadays data is cheap and abundant. That's why these techniques are again flourished. So learning general models from data of particular example, we use this and building a model that is good, useful to approximation to the data. So these are the, you can say, machine learning, where, and when we use machine learning, so where human expertise does not exist, like we are traveling some unknowns, like navigation on Mars. We don't have any factual information about the Mars. So uh, we can use such type of automatic learning technique. We can collect some data, we can take picture of the surface and then further analyze whether water is available, how surface, some rocks are there, what is. So where human expertise does not exist, we can use ML techniques. Or sometimes humans are unable to explain their expertise, like speech recognition, face recognition, driving. Okay, you know driving, but if someone will ask, we can't explain, because we learn driving through experience. You may read hundreds of driving book, but we cannot drive with the help of this knowledge only. Uh, uh, we have to learn only through practice. Simply the speech, we are able to immediately, we are able to recognize the speech of anybody, but we cannot explain the reason how, by which attributes we are recognized. So humans are unable to explain their expertise. In that case we can use, and one part of artificial intelligence, you may be aware that explainable AI models, explainable, this shape and lime, and these models are used nowadays, because we can explain the result of our model, how we are reaching to this conclusion. If uh, we are predicting whether this image, this diagnosis report will lead to the cancer, that we have also explained the reason why. So this explainable AI is playing a significant role for this. Sometimes the solutions are changes in time, like routing on computer network, or browsing history, or driving. So for this frequent adaptable environment, we use the machine learning, because as a human we cannot frequently do this. Solution needs to be adopted in particular cases, like biometrics, speech recognition, spam filters, or getting insights about complex problem and large amount of data. So in nutshell, when we need generalize from experience in non-obvious way, we need some machine learning techniques. So these are the some reasons why we need machine learning techniques. So the learning problem, as this data is cheap, abundant, knowledge is expensive, scarce. So learning from data is used in situation where we do not have any analytical solution, but we do have data that we can use to construct an empirical solution. And these are the some examples, like learning plays a key role in many areas of science, finance, and industry. like predicting whether the patient hospitalized due to heart attack will have a second heart attack. This prediction is to be based on demographic, diet, and clinic measurement of that patient. So you may have seen the heart disease prediction Kegel dataset and UCI dataset, and where you will find the many research papers like different attributes, and they will predict whether the person, when the person will probably get this heart attack and the hospitalization required. Predict the price of stock in next 6 months. Many this prediction models are available for stock price predictions, identifying the numbers in handwritten zip code from the digitized image, estimated the amount of glucose in blood for diabetic person from the infrared absorption spectrum, and identify the risk factors for prostate cancer based on clinical and demographic variables. So these are the learning problems, and in these problems, some domain expertise is required, as well as the knowledge of algorithms is also important. So problems for which existing solutions required. Why we use machine learning? Why use a machine learning? Because problems which existing solutions require a lot of hand tuning or long list of rules. So machine learning algorithm can simplify the code and perform better. Complex problem for which there is no good solution. It's all using traditional method, and this ML can play the role fluctuating environment and getting insights about the complex problem. Then how we can define the machine learning? So universally there is no agreement. This is the only particular definition of machine learning. So machine learning is set of methods can automatically detect the patterns, and these uncovered patterns are then used to predict the future data to perform all kinds of decision making under uncertainty. So to address the problem of analyzing huge amount of data so that they can be understood, providing techniques to automate analysis and exploration of large complex data sets. So tools, methodologies, and theories revealing patterns in data. This is a critical step in knowledge discovery process also. So all these aspects will form the key premises of learning from data, and there are some classical definitions for machine learning. These are the premises, and all these premises will lead to a classical definition of machine learning. And these are some example where every problem is not machine learning problem. So where we do not use machine learning, so like calculating payroll, sorting a list of word, web server, word processing, monitoring CPU usage, querying a database. When we can definitely specify how all cases should be handled, so for such type of things, this ML is not required. So these are some classical definition of machine learning. So first is machine learning is the art and science of programming computers so that they can learn from the data. And the Arthur Samuel, who coined this term machine learning, is defined machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. Then one more, Tom Michel, the famous author of this machine learning book on this machine learning. So machine learning is defined as a computer program said to be learned from experience E with respect to some task T and some performance measure P. If its performance on T as a measured by P improves with experience E. So this well-defined learning task can be defined by this tuple PTE. So ML is a subset, in general ML is a subset of large field of AI that focuses on teaching computers how to learn without need a program of a specific task. So these are some applications, business application like Walmart data houses mined for advertising and logistics, credit card companies mined for fraudulent use of card based on the purchase pattern, Netflix develop movie recommender systems, this information retrieval, communication systems, and genomics. You may be heard about the AlphaFold. The deep minds product this AlphaFold. So in these are the some areas where this ML can be applied. These are some popular example of ML every day. We use this email, so spam filters, the filtering the spam email and sending to spam folder is also a use case of ML. This Netflix, we are getting movie recommendations for new movies as per our preferences, as well as Spotify. They will recommend you other different sort of song depending on your choice. And these self-driving cars developed by the Tesla, Google, and other companies. These facial recognition services implemented in this Facebook, Printstars, and Google. This the deepfake, Google's DeepMind AlphaGo computer for sports, and these personal assistant systems, these wind predictors, and this IBM Watson for predicting the diseases. So these are some cases of machine learning. And reasons for growth of machine learning. So first is improved machine learning algorithms. Every day we are getting some new algorithms which will uh, overcome the limitations of the previous ones. So every day new algorithms are developed. So this is the one reason. Then availability of open source ML libraries, software, because it is very hard to write the software. Writing the software is too complex, and everybody is not expertise. So in machine learning, I will share in after few slides how this availability of these open source ML libraries. And over the period of time, there is a huge improvement in the data capturing, networking, and processing capabilities of computers. New sensors and input output devices for capturing the data. So these are the reasons, the fundamental reasons for the growth of machine learning applications in every area because of the reasons. So one is, as I said, that every day we are getting machine learning algorithms. So here you can say like simply decision tree. So many decision tree algorithms are there. Many alternatives are there. With small changes, we can customize our decision tree algorithm as per our need. Similarly, for dimension reduction, for feature selection, or for example, for anything, the huge large number of solutions are available, and most of the solutions are implemented in form of library. You simply call them. So these are the tools. The slide is old, so maybe some more tools may be added, but most of the are publicly available, like MATLAB. So MATLAB is proprietary, but there is alternative. Octave is a open source of MATLAB. We can use this. This scikit-learn, R. So machine learning libraries, NumPy, Panda, and this TensorFlow, CNTK for natural language processing, and the almost for everything. This GenSim for embedding your, incorporating your own word to vector model, and this for SVM, SGBoost. So these libraries are available. So this is also the one of the reason. All these, most of these are available in form of source code also. So we can do some changes and use them. So this is the little bit introduction about machine learning. And one more thing, how these machine learning programs are work fundamentally. So in conventional program, we need data as well as program, and then it will give output. But in case of machine learning, will give data and output, and we expect the set of rules or programs, or we expect some model, trained model. So this is the way fundamental how this machine learning is traditionally different from computer programs. So these are the different small differences, how traditional program will take input and how ML program will take input, how processing is done by the traditional program and how processing is done by the ML programs, and how we'll get the output from the traditional and ML programs. And this is again the same thing. So we can skip all these small example. This is the example how we can implement a spam filter program manually as well as by using the machine learning techniques. So now we come to the classification.
Sir, voice is not audible.
Hello.
Yes, yes, sir. Audible, sir. Audible, sir.
Yes, yes. So, with this brief introduction of AI and machine learning, we can move forward. So, as you can also, you've seen that there are different algorithms and the different techniques are available. So, there must be some classification how we can classify. So, we can classify these machine learning algorithms in different ways, like what data is available. So on the basis of availability of data, like data is available in form of labels, or data is available in without label, or data is available with partial label, or like this. So in the how this data is available to us, on the basis of availability of data, we can uh, classify this machine learning algorithms in different way, like supervised, unsupervised, reinforcement learning. So most popularly the semi-supervised learning, transfer learning. So these are the different types, one way of classification. Then how we are getting the data online or offline, or what type of models we are using, whether this model is parametric or non-parametric, whether it is generative or discriminative. So these are the some criteria, and these criteria are not exclusive. uh, we can combine them in any way, whatever we like. So and it is not like some algorithm is discriminative. It doesn't mean it cannot be parametric or it cannot be a non-parametric. So but these are the largely agreed classification criteria uh, where we can classify. So first we'll discuss the this availability on data. So supervised learning, as you are aware, its name is also name suggests. Yes. Yes. So in supervised learning, the data as well as the label both are available. Then we can such type of algorithms where learning is performed with the help of some teacher. What it means we know the problem as well as the sample solution. So such type of algorithms are known as supervised learning algorithm, technically, if both data as well as labels are available. This supervised, how this label, whether this label is continuous, available in form of continuous, or available in form of discrete, like in form of categories or continuous values. This supervised learning algorithm is further divided into whether it is a prediction, or whether it is a prediction problem, or whether it is a classification problem or regression problem. So if labels are available in form of real values, continuous values, then these are known as regression problem. If labels are available in discrete form or in form of categories, we'll say this is like you can take the example of stock prediction. So stock value can be of anything. So this problem, house price prediction. So these are the example of regression problems where any number can be predicted, any value can be predicted. And if we'll take the example like this email classification, whether the incoming mail is a spam or ham, or spam or genuine mail, then whether the person is diabetic or non-diabetic, whether this is case of diabetic retinopathy, or you may say which grade of diabetic retinopathy, where the labels are discrete. The labels may be of anything, like it is not necessary labels will be two only. It can be three, it can be four, five, but the labels will be the value cannot be of anything. So such type of problems are known as classification problems. So how these algorithms will work? Will take the data, like the training. For training, will take some data. If we are addressing the problem of natural language processing, then we'll collect the test documents. If we are addressing the problem of these biomedical field, like diagnosis of any disease by using X-ray image or MRI, then we'll collect the images. Then for speech recognition, we can collect the sound. What it means input can be of anything, whether it is text, numbers, or it is images, sound, or anything. So first we have to process this input. This raw files cannot be used directly, cannot be fed to the model. So what we'll do, we will extract some meaningful information. Like suppose we want to classify email, whether this incoming mail is a ham or a spam. So first we'll check the subject of email. Okay, if this email will consider this email will consist, subject will consist something like some acronyms or some exclamation mark, or then we'll see the body of the email. If body of email will contain like friendship, lottery, money, or something, reserve bank, or this sort of word, generally the spam email will consist. So we have to find out the some this email. The whole email is not useful. We have to find out some features. We have to extract some feature from email, or we have to define some attribute, and from attributes we have to extract the feature. What is the difference between attribute and feature? The one attribute may lead to multiple features. Like suppose a salary can be of one attribute, and this salary can be derived to what is the average salary, maximum salary, minimum salary, or what mean, median, or anything like so these numerical numbers are. So one attribute at least contain one feature, but one attribute may lead to multiple numerical values. So these, whether it is text, whether it is image, whether it is sound, this will be converted into some numbers in form of features, and this is known as feature vectors. So we will extract some features, and our raw data will be converted into feature vectors. Similarly, because we are using the supervised learning, in supervised learning the labels were all available. Labels, like we have some trained data, like in case of email, the Enron email data is available. So Enron email data means some set of emails are there, and their labels is also available. Whether this we are considering E1, so E1 is ham or spam, E2 is ham or spam. So such type of label data is available. So we'll also provide the labels in form to the machine learning algorithm. So now these features extracted from the this raw data and labels will be provided to machine learning algorithm, and this process is known as training. So after training, this ML algorithm, when once this ML algorithm will train, it will be converted into a model. So what is the difference between algorithm and model? So algorithm will train, and after training, this algorithm will be converted into model, and now we'll present some unknown data. So with some known data, means labels are known, we will train our model, and after training, this trained algorithm is known as model. So we can test, and we can get the result, whether this unknown new email will be spammed. So then the quality of this result will depend on this training process. Means how much data we are considering, what type of data, as well as the quality of data, and what we are extracting the features, like how these features are relevant. Just suppose we want to predict the academic performance of any student. Okay, and we have collected many features from our student section, like what is the name of the student, what is his father's name, mother's name, what is the school's name, or what is the height, weight, and we have collected so many features. Our data is huge, but whether all these data is relevant for predicting the academic performance of the student? Yeah. uh, Sometimes this data may not be relevant, because if suppose some student is tall or some small or some is heavy or some is lighter, then it will not contribute much in it academic. If some student is color, skin color, so all these parameters will not contribute much in their academic performance prediction. So what it means? It means we have data, but this data is not very much useful. Okay, so unnecessary we will complexing our model, it will not give a good result. So we have to keep in mind how much, which type of data which you do it, which type of pre-processing required, and these things. So in this way, the supervised training algorithm will work. There are many training algorithms for regression as well as for classification, as well as their performance can also be measured with the different measures. Like for case of classification, we'll use accuracy, precision, recall, and this ROC, this PRC. So different types of measures are there, specificity, and there are sensitivity. There are various measures are used to measure the performance of this classification problem. Similarly, we can measure the performance of these regression problems, like this house prediction, or where the labels are real values, like this mean square error, or this R square, adjusted R square. So these are the measures for regression. Then we can also compute the loss functions. So in different ways, we can also compute the performance of this model. Similarly, for unsupervised, so there is a difference between supervised. And here you will see that here there is no uh, label. So in unsupervised learning algorithms, the rest of thing will remain same, only the labels are not available. So examples of unsupervised learning algorithms, unsupervised learning techniques are this clustering, this association rule mining, dimension reduction, or this probability distribution estimation. These are the example of unsupervised learning, where the algorithm technique itself will find, suppose will give some fruits, and we also don't know about which fruit is which type of. So the algorithm will automatically sorted it on the basis of their weight, like attributes or features like weight, color, texture, shape. On the basis of the algorithm will learn over the period of time, and it will classify into different categories or different clusters. So how will all this unsupervised algorithm will definitely they will use some similarity measures, some distance measures, some distribution estimation measures, and on the basis of these mathematical tools, it will be able to cluster the objects without having any knowledge of previous knowledge of their categories on the basis of their, like if you ask to categorize or form a group of person, so different states people will be gathered at one place. So by simply seeing at their looking at their name, or their accent, or we can say their sometimes their color, or sometimes their face features, we can most of the time we will be able, because we are trained that these their accent sometimes tell there about their reason. So in this way, surnames are most likely, if someone is from X state, then this type of surname, like this. So these attributes can be automatically we can use and clustered in different way. Similarly, in semi-supervised learning, because in what is the problem with this supervised learning? Supervised learning are very easy, but the problem is the cost of labeling is very high. The labeling is done by the expert, like we are using the medical images, then these images are labeled by doctors. So the cost of labeling is high, and sometimes out of these huge amount of data, uh, huge amount of huge amount of this data, huge amount of this data. Some data may be labeled, like we have 1000 MRI images. So out of these 1000 MRI images, doctors may label 10, 20 for us. Okay, so semi-supervised example where nowadays the supervised and unsupervised are exhausted completely. So research is going on in the field of semi-supervised or reinforcement learning or like this. So here we can work with the partially labeled data. Okay, so most of the data is unlabeled, but some data is partially labeled, and some data is labeled. So we can start with this, and with performing some bootstrapping, self-learning or self-supervised learning techniques are there. We can move further, and we can assign the labels to the other images also. And once we will able to assign the image, assign the labels to the data, then we can continue. Similarly, this reinforcement learning. So the working of reinforcement, now the work is going on this, the lot of research is going on this field, this reinforcement learning. So in this reinforcement learning, the system is known as an agent, and this agent will interact with the environment. Okay, it will observe the environment and perform some action, and on the basis of this action, this agent will get some reward or penalty. So like if it will get reward, then it will move in this the same direction. If it will get penalty, then it will review its move and change the direction. So this strategy based learning, where we make a policy, and means the agent will get most of the reward over the period of time. So in this way, like this game playing or this self-driving car, or these are the example of this reinforcement learning. In game playing means first we have to move, then what opponent will move, on the opponent's move will decide our next move. In this way we will decide. Here this example is also self-explanatory, so we can use this reinforcement learning. Similarly, another domain, not not the basic, you can say the basic is supervised, unsupervised and reinforcement. The semi supervised is nothing but the form of the mix of supervised and unsupervised, where some data is labeled. And the another form of learning is, this is known as transfer learning. So in sometimes the challenge is, suppose we have trained a one model, we learn. So is it possible? Can we transfer of learning from one model to another model, or one task to another model, another task? Like we have expertise solving some problems. So can we use partially? Can we use this knowledge to, like we are very good in solving mathematics? Yes. So most probably we will also be good in solving the physics problems, because most of the mathematics knowledge can be transferred to physics subject. Although the problem, if you are good in mathematics, then definitely you will be good in machine learning, because all these concepts, all mathematical concepts are directly or indirectly used in machine learning. So machine learning is nothing but the you can say the applied mathematics sort of things, where we will apply, like derivatives are used to find the gradient, to find minimum, probability is used, probability distribution is used, statistical techniques are used, integration is used. So every almost every mathematical concept is used in machine learning. So the question is whether we can transfer the knowledge of solving a one type of problem to solving the and what will be the advantage of this? The advantage of this will be, it will save time. So in some domain, labeled data are in short supply, and the calibration effort is very expensive. So the learning process is time consuming. So reusing a model that was trained while solving one problem and applying it to solve but different related problem. Like if you want to learn driving of a car, and we already know how to drive the tractor, then possibly we learn easily to drive the car, because partially we can transfer this knowledge of driving a tractor into driving a car. So this transfer learning is of two types: homogeneous transfer learning, if the input feature space between the source and target program is same, then will there homogeneous transfer learning. Heterogeneous transfer learning, if the input feature space between the source and target data is different, then we'll use the heterogeneous. So homogeneous means the feature space of both the source task and the target task is same, and if there is a difference between their feature space, then we'll say this is the, so this is our active learning, where learning algorithm can choose its own training example, then we'll say this is the active learning. Similarly, this online and offline learning, so how we are getting data, this online means we are getting data at once, and offline we are getting data one by one. Okay. Similarly, the models can be divided into generative and discriminative models. So this generative and discriminative model, there are two different approach. So this discriminative models try to directly learn uh, the learning function that maps. Actually, what we learn how to map the input vector to the output label. Okay, this is our machine learning problem. So y equal to fx. So where y is x is our input and f is our function which will map to the input to the output. So this task can be done in two ways. So discriminative model, they directly learn from the function, and these models can be of deterministic or distribution free model. What it means classifiers, or we can say the discriminative classifier, try to find a function without using any probability distribution or without any assumption of the distribution of, or the distribution of underlying data set following which type of probability distribution. So these classifier outputs a label of each sample directly without providing the probability estimation for the class. The example of this discriminative is support vector machine, where we'll draw this discriminative line. So what they will learn from these data points itself, not their distribution. K nearest neighbor, decision tree, these are some example of discriminative model. Which type of discriminative model? Deterministic or distribution free discriminative. Similarly, the probabilistic classifiers. So models which first learn the posterior class probabilities from the training data, and based on these probabilities assign a new sample x to one of the label or one of the class, and these classifiers are known as probabilistic classifier, and example of such classifiers are logistic regression, neural network with sigmoid and softmax functions. So these are the discriminative, the description of discriminative classifiers. And generative classifier, so generative model learn from the distribution of the input before estimating the class probability. So in generative model, first the model will learn what type of distribution is followed by the use data set. So more specifically, you can say the generative model first estimate the class conditional densities and then prior class probabilities from the training data. Or in other words, they try to learn how the data was generated in class. Example of generative model is this naive Bayes and these Bayesian networks, mixture, Gaussian mixture model, hidden Markov model, and LDA, linear discriminant analysis. So these are examples of generative model, where we will generate, it will generate the probability distribution of data. So we'll come to, hello, if you have any query, please ask. Hello,
Yes, sir, audible, sir, audible.
hello, I am audible.
Yes, sir, yes. Participants, you may ask.
Hello,
Yes, sir, audible.
yes. If you have any query, then please you can ask. Okay. So this is all about the classification of machine learning algorithms. Now we come to the specific like supervised algorithms. As I said earlier, in supervised there is X as well as Y. X is our input data and Y is our label. So, but this data is not available like X and Y. For first we have to extract this data. So first there are some real problem. Real problem like we have some uh, medical images. Then out of these medical images we have to formulate the problem, and for formulation we require domain knowledge. Like in case of medical we require the help of doctors. Doctor will inform, suppose doctor will inform us about the relevance, like we are analyzing some images, then doctor will tell us these regions are the possible cause of this particular disease. So we have to, regions means what is their dia or their illumination, or they will suggest us some features and then we will extract the feature. So first the will take any problem, will formulate the problem, collect the raw data, and from this domain knowledge expert or for medical like this doctors help in formulation of problem as well as interpretation or explaining the significance of features uh, which is possibly extracted from the raw data, and then we will prepare training, and the trained data will pass to the algorithm, and then we will give some unknown data X and we'll get the classification, prediction, or regression. So this is the way how these our supervised learning models will work. Here, the more specifically, the supervised learning frameworks y equal to fx plus this EI. So this y is our output, x is our data input features which are extracted from, and this f is a prediction function. So ultimately, what we are doing, we are learning, our model is learning this f. This f can be of any function which will map this, which will relate every input data to this y. And during in this process, some errors are there, and these errors can be some errors, random error, and some errors are irreducible errors, although some errors can be minimized, but some errors are irreducible errors. Irreducible error means we cannot remove this type of error. So this is mathematically what is our machine learning. Mathematically, machine learning is defined at y equal to fx plus ei, where this ei is representing the errors. So simple like this apple, tomato, and this cow. So apple, what this X is apple. So we are not pass. We will not pass the apple. We will extract the X is representing vector. So we'll extract the x1, x2, x3 like shape, color, and their weight and texture, such type of features from each object, and we'll pass these features, and this function will learn feature and will tell us about the. So first we'll collect the historical data, extract the feature, pass the label, and this ML model will be trained. Then this feature will, this ML model FX will be used for, this trained model will be used for predictions. Like here, this simple example where some size and color and price. So size of t-shirts, M, L, L, S, X, color, and these are the independent, and price is dependent feature, means the price will be decided by the size and color of t-shirt. So our model will pass these features to our model, and our model will predict some target price. So we'll calculate the difference between fx and y. Y is actual price, fx is predicted price, and will form the loss. We'll calculate the loss and we'll calculate the loss function, and we'll try to minimize this loss function. Similarly, for classification, the x1, x2, xp, these features are extracted, and this, so data will be presented in this form. So our model will be trained, and they will perform the testing. So automatically these features will be extracted, and model will predict whether this data will belongs to which class, A, B, If two classes are there, then what is where this first is A, B, or like this. So this is the basic way. Different type of features, like for image classification, we can use raw pixels, we can use histograms, we can use these descriptors. So in this way, different types of features can be considered for any data. So this is our overall explanation of how the supervised learning model will work. Now, quickly we'll see what is this naive-Bayes classifier. So this naive-Bayes classifier is, you can say, the generative classifier. Okay, so it will generate the probability of data. It will means in this, first we have to learn about the probability distribution of data, and there are three concepts of probability, like marginal probability, joint probability, and conditional probability. So marginal probability, if A is an event, then the marginal probability is the probability of that event occurring. For example, if we have a pack of traditional playing cards, an example of marginal probability would be the probability that a card drawn from pack is red. So P red will be 26 by 52, because out of this 52 pack of cards, 26 are red and 26 are black. Similarly, the joint probability is the intersection of two or more events. If A and B are two events, then the joint probability of two events is written as P intersection B. Example, the probability that a card drawn from a pack is red and that has value 4. So probability P red and 4. So P red and 4. How many fours? Two fours. In red, two fours, diamond and heart. So 2 by 52, 1 by 26. So there are 52 cards in the pack of traditional, and that two reds, one is heart and another is from diamonds. Similarly, this yes, one more thing, this joint probability is interchangeable. Whether we write it 4 and red, or red and 4, or P intersection B, or P probability of B intersection A, both have the same meaning. Similarly, the conditional probability. So the conditional probability is the probability that some events occur given that we know other events that have already occurred. If A and B are two events, then the conditional probability of A occurring given B has occurred, written as P A by B. Example, the probability that card is a 4, given that we have drawn a red card. So probability P 4 by red will be 2 by 26. So there are 52 cards in the pack, 26 are red, 26 are black. Now because we have already picked a red card, we know that there are total only 26 red cards, and we have to choose from this only. So hence the first denominator is 26. Now these three probabilities can be linked together, and in conditional probability, the P by B, P A by B is not same as P B by A. While in case of joint probability, P A intersection B and P B intersection A is the same. But here this is not the case. And we can link this probability. You may be aware, otherwise we can. So, here you can see the example, like if I will say P, if I have cute puppy in my lap, okay, in my hand, then what is the probability of P cute puppy if I have puppy in my hand, and what is the probability of cute, of cute? Okay. Similarly, it cannot be same at like that. The cute can be of anything. It is not necessary that puppy will be cute only. It can be of the small children or kitten, or it can be of anything. So it's not like both things are not same. And if we do some mathematics, then there is a linking of probabilities. We can derive this. the general rule where this conditional probability, joint probability, and marginal probability can be linked by this formula. So, why we discuss this probability? Because in naive-Bayes or in Bayesian learning, the probabilities, these three types of probabilities are used, and actually this probability is the way of guessing. Suppose we want to guess. This is suppose we encountered a person. We are looking from his or her back, person's back. It's back. Okay, and the person has a long hair. We with certainty we cannot say whether the person is man or woman or person is male or female on the basis of long hair. But so the Bayesian is a the guess guess upon guess with some base rules. So if we have some more additional information, if we have some more additional information, then our belief will change. Like our notion is like if someone has long hair, it means uh, she is a woman. It is not necessary. If will just suppose if you have someone has long hair and you will find that person in such type of places where only men are allowed, then this is the additional information. So if will all these facts will be plugged to a particular formula, and this Bayesian, this is also known as the guessing by Bayesian. So this Bayesian statistics is very useful. The same time, this probability distributions. So different, as I said, that whatever data we are using is followed some distribution. Distribution means like suppose we want to do a survey. What is the height of students in our institute? So obviously they will follow. Yes. Hello.
Sir, yes, sir, yes, sir. Audible, sir. Sir, time is actually over, sir, but okay.
Hello.
Yes, sir, audible. Your voice is audible,
Yeah.
sir.
So
Actually,
yeah, every in every so suppose we want to know the marks of the student. So marks will follow some distribution like from 10 to 100 or from 0 to 100. What is the minimum and maximum mark? So some student will be have around 30. Some students have maybe around 40 like this. So whatever data we are using in our problem, so they will follow some distribution. Distribution means how this data is scattered. So these distributions are defined by some properties. Like you may be heard about a Gaussian distribution or normal distribution. So what is Gaussian distribution, normal distribution? This curve is for normal distribution, Gaussian distribution. And most of the time we assume that our distribution, whatever means, if we don't have any understanding of any other distribution, then we'll assume that this Gaussian distribution. So there, this is the normal distribution. This is the Poisson distribution. What is difference between this normal distribution and Poisson distribution? You will see here the normal distribution is a continuous function. It is defined each and every point. The Poisson distribution is discrete. So the application of Poisson distribution, the Poisson distribution can be used for different types of problem. Normal distribution can be used for different. Then this normal distribution is defined by its mean and standard deviation. In case of Poisson distribution, mean and standard deviation is the same. So the Poisson distribution is defined by the mean only. So in this way, for every this normal distribution slightly, it is rightly this log normal is slightly skewed. This chi squared, this students, and means these like this uniform distribution. Like we are doing the trial for flipping the coin head and tail. So every time that this distribution has uniform, means there is a 50% chance of. So Bernoulli distribution, so uniform distribution, Bernoulli distribution, binomial distribution, geometry. So these are the, you can find this link is also given.
sir, session for this time is actually over. So thank you, sir, for your efforts to enrich our minds with our very informative lecture. Your explanation for these issues with additional method for solving traveling assessment problem and the use of AI to handle such situation was excellent. You differentiated intelligence from artificial intelligence and informed us about the various types of artificial intelligence like ANI, AGI, and ASI. You made us aware about AI, ML, and DL with visual aid of Venn diagram. Differentiated between learning and memorization. Made us know when machine learning is used. Gave us various examples of learning problems. And also told us about the cases when ML is not used. You also briefed us on classical definition of ML and reasons for growth of ML. Difference between ML and traditional was also made aware. Extensively discussed supervised learning, unsupervised learning, transfer learning, and active learning. Informed about the difference between generative and discriminative models. You also made us aware of the supervised learning framework. Thank you once again, sir, for imparting us with your knowledge. Thank you, sir.
Thank you, and I'm sorry that some essential points are just because of the mismanagement of time,
Yes,
or
yes.
something are left from my side. At least I required 10 to 15 minutes, but I can understand that next speakers may be waiting,
Yes, yes.
so it's okay. But yeah. So it's if you allow me, then
Actually, next issues person has joined, so if he
okay,
will
okay.
tell us,
Yes,
then
yes,
of course you may proceed further.
yes. So thank you, Dr. Dilip, and for giving this opportunity, and all the participants. Thank you for listening carefully. Thank you. So now you can admit the other speaker. Okay, I stop my presentation.
Yes, thank you, sir. So, Arvana sir is online. Sir, Dilip sir, actually I have asked from next person. He came online, but right now I think he has left. He has seen that you are giving the lecture, so he told me that if he wants to continue, he may continue for 10 minutes. Sir, would you like to continue? So our next resource person has joined. So a very hearty welcome to our speaker, Professor Prabhat Kumar sir. We are very delighted to have your presence in our STC. Thank you for providing your valuable time for this STC. I am going to introduce about our resource person. Professor Prabhat Kumar has completed BE in Computer Technology in 1999, MTech in 2005, and PhD in area of wireless sensor network in 2014. He has a vast experience, more than 20 years in the field of teaching. He has served as a lecturer in R.P. Sharma Institute of Technology from November 1999 to 2005. Then he worked as an assistant professor CSE department in IIT Patna from 12 December 2005 to 22 July 2018. And from 23rd July 2018, he has worked to September as an associate professor. Then thereafter he has continued as a professor. He is currently holding various administrative responsibilities among being chairman, computer and IT purchase committee in IT Patna, professor in charge IT services in IT Patna, PhD coordinator for CSE department in IT Patna, and various others. His past administrative responsibilities include HOD CSE in IT Patna for 3 years from 2016 to 2019, chairman, department research committee CSE in IT Patna, state student coordinator of the state Bihar under region 2nd, Computer Society of India, and many others. He has authored more than 120 articles, which include 53 international journals, 60 international conferences, 2 books. He has also delivered more than 25 expert lectures in various prestigious institutions like IITs and IITs, and has been chaired in session chairs in various international conferences. He is also a member of various prestigious organizations and societies like senior member of IEEE, ACM, CSI, ISTE, International Associations of Engineers, Internet Society, IFIP Working Group, etc. His research area include wireless sensor network, IoT, cyber security, data science, data analytics. He has supervised more than 6 PhD and more than 10 PhD are doing under his supervision, and have also guided more than 25 MTech scholars. Sir, welcome, sir. Over to you, sir.
Thank you, Dilip ji. And first of all, I would like to welcome all the participants. And without wasting the time, I'm sharing my screen. Is my screen visible?
Yes, sir. Yes, sir. Visible, sir.
Voice is clear?
Yes, sir. Clear, sir.
Okay. Thank you. So, okay. Is it full screen now?
Yes, sir. Yes, sir. Full screen, sir.
Okay. So the today's discussion, the topic is AI-enabled IoT for biomedical engineering, aligned to the theme of the short-term course. So basically, biomedical engineering is a very emerging area, and medical plus engineering is very interesting. Even many of our IITs have been asked to open medical colleges, and we also at NIT Patna, we are collaborating with Rajendra Medical Research Institute, AIMS. Just to inform you that the present senior medical officer, the doctor of NIT Patna, is also a PhD scholar of computer science department. He is doing PhD in our department, and I am also his research member. So just I'm informing you that engineering and medical, maybe for the first time, it is coming together, and the benefits are enormous. And why it's important and why today it's coming together is the reason is AI, the artificial intelligence. So together this becomes, or this makes a very interesting area, AI plus IoT plus biomedical engineering. So I've tried in whatever time I have to keep it introductory so that, the audience is quite mixed, and try to give you a glimpse of how technology and in which area things are going to be. So the agenda will be starting with introduction, and then humans, AI, machine learning, how they interact together, and then how it can be helpful in the healthcare and biomedical thing. So biomedical engineering, as discussed, the application of engineering principles and design concepts to the medicine and biology. It provides electrical, electronic, electro-optical, and computer engineering support to clinical and biomedical applications. Improves healthcare. The major part goes in diagnosis, monitoring, as well as therapy. So it has the potential, this addition of this engineering part with biology, helps in all the aspects, diagnosis, monitoring, and therapy. We will see how. So that's the biomedical engineering, bioengineering. The healthcare sector, just to give you one little, so as we know, we are the largest population as a country on this planet, and that requires quite a good healthcare system. And this landscape is changing, like Indians with the growth in per capita income, good food, and Western culture, the obesity is growing, as well as a large number of population below poverty line. So there are diet issues. And one another thing which right now we are at advantageous position, that is the young population right now is quite high in India as compared to even China and other Western countries. But 20 years, 30 years down the line, it will change. So our healthcare system should be ready for a large number of old population in nearing future. So that system should start working right from now. So 75 to 80% of healthcare spending is on chronic disease management. Huge market for new systems capable of improving productivity, minimizing costs, shift healthcare from hospitals to home. As we could have seen in the COVID situation, the beds were not there. And one another aspects which came to highlight during COVID was that people were getting recovered more better in home environment than in hospital environment. So what if we can bring hospital to the home, give the benefit of both, give the benefit of hospitals in the home environment? That's where IoT can come into and become very handy. So if you see the healthcare expenditure in India in billions, you can see it is rising. And these rising healthcare, why we computer people are talking about it, once the expenditure from the government, it creates a huge job market. It gives you a potential for a new job environment. So many of BTech students are also there. So you can write some good projects and get some funding. So the healthcare sector market segments, if we try to divide, the pharmaceuticals companies are one part, diagnostics are the other part, medical equipment and tool manufacturers, we are dependent on China to a large extent as of now, and then the hospitals. These are the market segments. Still, India requires more in terms of investment, because lakhs of people die due to insufficient access. And as I discussed, COVID has already showed us where we are lacking. So IoT, how it's going to help us. So we will start with the IoT architecture and its application. Internet of Things has the potential to change the world just as the internet did. Kevin Austin predicted it in 1998, you can name 25 years earlier. He could foresee that how IoT will change the things, and now we are seeing the effect of that. Formally introduced in ITU in the International Telecommunication Union Internet Report in 2005, it means a worldwide network of interconnected objects uniquely addressable based on standard communication protocol. So it's not computer, interconnected objects. Those objects which can support standard communication protocols. And that's what IoT had changed the scenario. Previously, we used to talk about connecting computers, connecting laptops, connecting mobiles. Now, any object has to be, and those objects can involve a huge diversity of objects. So IoT is not only about communication, it involves much broader aspects like intelligence using data analytics, machine learning, artificial intelligence. So when we combine this AI and analytics with the power of IoT, things change a lot. What we are talking about today is anytime connection, any place connection, anything connection. So anytime and any place, that was ubiquitous computing. Now anything takes us to a new level, and that is IoT. And now we can see human to human, human to things, and the latest is things to things. That means why one human, if I need some services, why should I get involved? Let us say I have invited one of my friend to a dinner tonight. If I tell my mobile phone that kindly arrange, like Alexa and Siri, let's say I say Alexa kindly arrange. Now that Alexa using these features should be in a position to know my preference, know my friend's preference, which hotels we prefer, what timing normally we take our dinner, based on the previous history of those kind of events, and then they can schedule everything. And without our intervention, even my mobile phone can talk to my friend's mobile phone and set up the things without either me or my friend. Or that means humans getting involved. And that is the future. That's where we are working. Already I have filed patent on that. So things are moving into that direction, that one thing or one object can talk to another thing or object and get the let's say services done for us. So that is the future of IoT. So you can think about small applications which can communicate between each other and make things happening. So many of the students are working on those kind of projects. So I want you to think on this part, that this IoT or whatever computer science, we are a genetic algorithm, evolutionary algorithm, what are we trying to do? If you think deeply, what we are trying to copy what God has already given to us, So it's nothing that we do not know. We know, but we do not know how it works. Now we are trying to copy. Like in the IoT architecture, 3 C's are very important: collect, communicate, and control. Already our body has those things. So we are trying to make analogy. So you see, for collection, we depends on perception. Now we require sensing layer. That means sensors can collect data from environment in IoT, right? We have what in human body? We have sensors given by God. Now the second thing is, whatever you sense by your hand, by your tongue, the tongue is not in a position to know whether it is what ingredients, or whether it's salty or whether it's sweet. That sensation or that information comes from the brain. So though at the end it's your tongue or your hand, the signal is communicated to your brain. Similarly, here also a sensor may be at the end point, but that sensor cannot, or in all situations cannot take a decision. It will get the information, sense it, and communicate it over a network to the control center, which is the brain in human body. And here it can be a cloud, it can be a central processing unit. So that's where the application services will run. That means it will analyze the data and take decision. And again, it can even use actuators to control the things. So this is the IoT architecture copied from, you can say, God architecture. Now, as we have told, new terms might be for many of you, sensors. Now, sensors are, when we say IoT sensors, it can include bigger sensor also, but with technology improvement, with electronics and circuit and microchips. Now, these sensors are very tiny, low power, limited memory, short range communication device. The objective is to monitor activities, gather and fuse information, communicate with global data processing units. So these are the major objectives of deploying sensors. Now, a lot of improvement has been made in the sensors field. Just imagine, people are working someday. If somebody is able to manufacture a sensor which can detect COVID, that company will become $1 billion company overnight. So they are working, but so far COVID cannot be detected using sensors. We are trying. So a sensors has these components: a radio unit, a microcontroller, sensors, actuators, and definitely it requires power. Now this power, again, a lot of research is going on. They have developed sensors where you don't need to give external power. Just by the press of a button, the pressing itself produce enough energy so that a signal can be communicated between A and B. So a lot of efforts are going on again in the sensor field. So finally, any sensor must be in a position to sense and must be in a position to send that information. That's the first part. As you can see, if the sensor size increase, you can put in some battery, you can put in antenna, you can put some additional, even mobility is possible if you put in those kind of kits. So the sensing unit collect data from the environment. Now what kind of data? It can be magnetic, light, sound, chemical data, bacteria, viruses, proteins. So all kind of sensors are available now. With biomedical engineering, we require further newer types of sensors, and a lot are already there. We will see in the ahead slides. Then a microcontroller, that's the brain, gives a smart object their intelligence. It has built-in memory, timers, hardware. So many of you might be working on actuators and sensors. A radio transceiver is required for communicating both ends, and then the power source may be solar, maybe vibration, as I told you. You don't need it. Then there can be active power sources, like if required in IoT environment, you can give an additional power through battery or through direct wiring. Just imagine the types of sensor. As I told you, this is one slide. It gives you a but biomedical, we will have a separate slide on that. But here, as you can see, the chemical, the flow, the force, load, torque, strain, pressure, leaks, magnetic, electric, acceleration, tilt. Even in your mobile, you can play games where, you know, they can detect whether you're turning your mobile, or all those kind of sensors are already there. Then here where core computer science come into picture. Who writes the protocol, the set of rules? So it's we. And when you say IoT intelligence, it can be PAN, LAN, MAN, WAN. Once you are on internet and cloud, you can control anything from anywhere. And that's where so many technologies need to talk to each other. That's one. So that's where we need proper protocols, we need proper support, and at many times government regulations also comes into picture. That let's say you have developed a project in Indian environment, that wireless spectrum may be free in India. You go to England and then suddenly you are asked to pay for that. So these kinds of issues are also coming up. But slowly the government is converging, and better services are being given to common man. So I'm sharing one video where you can see the future of services and how these sensors based services is going to help us, or rather we like or not, it's going to enter our life. If the audio is not, then please let me know. I hope it will go. See the video. Was the audio good?
It was nice, sir.
Thank you. So the last part, you could see that your data has a story to tell. If I ask you, maybe if you're a student, the answer will be different. But if somebody asks me that what's more important to you, the cost of your mobile or the data inside it, I don't need to think, the data inside it. So the data has become important, but it was not the situation 10, 12 years ago. Today, your data can tell many things about you. And that's where the entire world is looking, that's data analytics. And those data, if communicated properly in real time and with proper data analytics, it can, or it is changing the entire world, Just remember, if you are searching something, you go on Google and you search something, like, let's say you search a ticket from Patna to Delhi, and don't buy it. And now you start doing something else. You will get ad based on that. Cheaper ticket from Patna to Delhi. You can easily go to Patna to Delhi. It will automatically come. How it's coming? Your movements are being tracked. Whatever you're buying, whatever you are visiting, how that is being done, it's we, the computer people, the engineering guys, we are writing codes. Our each movement is being tracked. So the more we are dependent on data, on technology, similarly, a parallel issues of security, privacy will come up. So whatever protocols has already been written are not in a position to be deployed as it is in the present scenario. Government of India is very much worried about the security concerns. I look after the IT services of NIT Patna for last so many years. I'm getting letters. We are trying to upgrade the IT infrastructure from the security and privacy part. The data leakage, nobody wants their data to be. So that slide, though it showed in a proper perspective that your data can be useful for automating things, and your car can talk to the shop. No, neither the shopkeeper is involved, neither the car driver is involved. If there is some coupon, the car will take the coupon from the shop. No need of human intervention. So that's where IoT can go, and the applications, I don't need to tell, from smart homes to logistic and transportation. One is healthcare. Today, the focus will be healthcare, but smart cities. In future, there will be engineering courses on the smart cities, engineering in a smart city. That's how the scenario is going to change. Normally, we, our BTech and MTech student, we ask them, if you're planning an intelligent home, what technology you will use, where to work. So this is one scenario of a smart environment. They do some things. Now, this is the future of transportation, Right now, just imagine if a train is scheduled from station A to station B, it will stop at all stations, irrespective if somebody is boarding from there or stopping there. Why? No intelligence. Everything is fixed. It will stop for a particular time. 10-minute stoppage, even nobody is coming down or boarding that train, it will stop for 10 minutes. Similarly for the buses. But tomorrow, things will change. Everything will communicate to each other. If there is a ticket booked for that station, or a passenger booking a ticket from that station, then only you need to stop. So those kind of things, interconnectivity will work. The buses will be aligned according to the train. So slowly it is happening in India. But if you go outside, one ticket can enable you to travel in train, buses, as well as on waterways. So these things will come to India also very soon. So transportation in one area. Now let's move ahead. Humans, AI, and machine learning. Whatever we are trying to do, who is the ultimate beneficiary? It's the humans. We want services for whom? For humans. Now, as I told you earlier, AI is copying what? The way humans do. That's AI. The way humans do. So let us see how humans do. Let's think in a completely a new perspective. Our memory. Human memory process is a distributed process which runs parallelly in different brain areas. It will be new for many of you. So as you can see, there is a episodic memory and there is a semantic memory. So bike riding, how to ride a bike, that will come from a procedural memory. So memory again divided into many parts, and then that works together. I know it's in the next slide you will again get to know how many types of memories. Here, what are the functionalities of human memory? Cognition, encoding, recalling, consolidation, procedural learning, semantic learning, inferencing, forgetting. Everything is part of human memory. We have been built like that. Even the last forgetting is very much essential. You just see when somebody very close to us go away due to death or something, even forgetting is required. You cannot do your normal work for maybe days, for weeks, but slowly human, your memory again enables you. So it's not that it happens automatically. It is built like that. So that God has built the memories like that we have all these functions. As you can see, for that to work, our memory is divided into three parts: long-term memory, short-term memory, and sensory memory. Now, sensory memory is very limited. It's not of much use, the immediate part. The short-term memory, that is the working memory, what you remember. And the long-term memory, you remember it from a different perspective, like episodic memory or semantic memory or procedure. You have learned something over the year. That's the long-term memory. You are using it with the help of short-term memory for working something. So right now, like you are studying engineering, or that's affecting your long-term memory. You are learning something. So sensory memory, it can be ultra short-term memory, buffers the sensory information. It can't be prolonged. That's the difference between sensory memory and the working memory. Even if you try, you cannot prolong that ultra short-term memory. The working memory, it holds around 7 elements up to a minute. And if you want to go take it to the main memory or the long-term memory, then you need to recall, you need to rehearse, like बचपन में जब पोएम याद करते थे तो बार बार उसको, so that आप उसको repeat करते थे, so that it goes to the main memory or for the long-term memory. So here you can hold, like carrying over a number in a subtraction. If you are given to add something or to multiply something, you can remember 5, 6, 7, 8. After a certain time, you start forgetting because it has its own limitation. Then the long-term memory, once you see something over the years you have seen, and then even somebody not educated, he know that what at work, if there is a birthday event, if somebody is cutting the cake, nobody goes and tell him that it's his birthday. He has seen it over the years that the person who cuts the cake, it's his birthday. So it's not written in the book. So through the episodes, through the happenings in their life, through you learn things through context. That's the long-term memory. So I won't go much into that detail, but it was just a discussion to bring you to this slide, cognition, because AI is the background starts from here. The mental action or the process of acquiring the knowledge, understanding through thoughts and senses, that's the human cognition. And now we have to copy this in a machine. That means how it can acquire knowledge, how it can understand, how it can make its own sense, it can answer by its own. That cognition is being transferred to the machines. And that is where there is a debate whether you should allow machines to take your decision, or you see the English movies, Transformer, and the machines versus human fights. So once we are giving cognition to the machine, the thinking capability as well as the decision making capability, and that's where a lot of dangers can come in. There's two sides in the society, some for, some against, but you are either side, you cannot stop from happening. Already you know where AI is going. Use existing knowledge to create new knowledge. Examples: attention, comprehension, reasoning, memory, language understanding, perception, and last but not the least, decision making. So if you allow them to take a decision, well. So coming to AI, science and engineering of making intelligent machines which can have cognitive capabilities, which can learn and think and decide. Intelligence is the computational part of the ability to achieve goals in the world. Intelligent machine mimics the cognitive functions associated with human mind. So that's why I kept something about human mind. Machine has to mimic what? The cognitive functions associated with whom? Associated with us, our mind, the way we do. That's what is expected from a machine. So the goals of AI: to understand intelligence in order to model it, to build systems that exhibit intelligent behavior. So there is one Turing test. Some might have heard it. Human beings are intelligent, no doubt. For machine to be intelligent, it must produce response that are indistinguishable from those of a human. That means here there is a person and he's getting two kind of response, one from machine Z and one for person X. And now if he is asked who is machine and who is human, and if he cannot tell the difference, that means the machine has passed the Turing test. So right now we are having those kind of machines like ChatGPT. You are learning. If a essay is written by ChatGPT and you are asked whether some human has written or intelligent software has written, it's very difficult to predict. They are doing it quite nicely. See, AI as a complete perspective. So many branches, interdisciplinary branches has come together. Computer science, obviously, but started from psychology and cognitive sciences, reasoning, learning, planning, then the mathematical part, then the psychology, then the computer science, and the outputs, the game theory, language, image processing, robotics, navigation, and the list is endless. So all these things, uncertainty management, knowledge equation. So AI includes a lot of things. If you're doing PhD in computer science, especially in top universities of the world, they might ask you to study psychology as a paper. They might ask you to study cognitive science as a paper. You cannot say that I'm a computer student, why I'm asked to study psychology. Because we computer people, we have to serve to the common people. So our software or our robots or whatever we make has to communicate with the normal people. So that's where all these things are together in AI. The applications: gaming to business, entertainment, medical field, AI applications at this stage. Here comes the coding, embedding intelligence at program level. So this kind of coding, A is greater than B, B is greater than C, then A is the greatest, that we study right from, start learning programming. So is it AI? If there is an algorithm, if there is if and else, is it AI? Aren't we? Then AI existed from 1970 because these kind of programs exist from there. So how it is different? Let's say I'm writing a chess program and I'm one side and you are another side. So whatever you play first, I will do a repeat, one step from my end, one step. If I write these kind of program, if you play this, I will play this, and replace me with a computer. It can play as Prabhat will play, as I will play, because I have written whatever you do, I have one answer for it, and it will based on if else. So what is the wrong in that? The problem with that is, if you have a set of steps or a sequence of steps by which you can defeat Prabhat, and if Prabhat is replaced by a machine, by the same sequence of step, you can defeat Prabhat a number of times, because the sequence of step is predetermined, it is written, hard-coded. So whenever you play that move, the program will play the corresponding move. So it's not learning. So if you can defeat it once, you can defeat it 100 times. Just remember how you have defeated once. But if Prabhat is playing, if you defeat me 5 times using the same steps, I will change my strategy. At least I will try to change, I will try to beat you. That's the human part. So how can the machine do that? That's where, Deep Blue, IBM version of AI, Kasparov, 3 wins, 2 draws, 1 loss also. Then Deeper Blue, first match won against world champion. So slowly, you see machines getting that cognitive capability, learning from their mistakes, not doing the same steps. Here, if else is gone. Now here, I am detecting the movement, but before taking my step, it's not if direct else. I am using my knowledge. I'm using the repository, the information, or whatever I have learned. Those, you see, if you are getting beaten by one of your friend in chess, if you play with him 10 times, it is possible you will start beating your friend, because you will learn. That's how we are writing programs which are learning. So learning is a very important part in artificial intelligence environment. Environment is not static, it is rather dynamic. Usually incomplete information about the environment is available. Use the sequence of percepts to estimate the missing details. That's the actual environment. You have to find the missing details. Hard for us to articulate the knowledge needed to build AI system. Example, try writing a program to recognize visual inputs like various types of flower. How you will write a program? How to input those things? But we can train a system to recognize. So learning denotes changes in the system that are adaptive in the sense that they enable the system to do the tasks drawn from the same population more efficiently and more effectively the next time. Just see this once more. It denotes change in the system that are adaptive in the sense that they enable the system to do tasks drawn from the same population, similar tasks, more efficiently and more effectively the next time. That's where learning comes. Otherwise, what you say? कि कुछ नहीं सीखा, same गलती कर रहे हैं. So that's where learning is important. And if you add this machine, it's a hot topic. Everybody wants to work in machine learning. So machine concerned with programs that automatically improves their performance through experiences, does not require FL's type logic. Machine learning helps to find the hidden patterns in vast amount of data that is just too big for humans to analyze. So when the hidden patterns are difficult for direct human interpretation, then you are dependent on the machine. And in the machine learning, there are so many techniques like deep learning, clustering, principal component analysis, regression analysis, and the list is growing. So let's see. Deep learning, a slight introduction so that when we go to the actual biomedical engineering, you can understand where to put in what. It's a subset of machine learning, uses multi-layered neural networks. It's a super power. With it, you can make a computer see, recognize, synthesize novel art, translate languages, render a medical diagnosis, or build pieces of a car that can drive itself. So input layer, output layer, there are lots of hidden layer now, number of layers, and what is done at each hidden layer may not known. You are giving an input, you are getting an output. Even the designer at times doesn't know at what layer what is happening. That's the power of deep learning. Let's say there are 10 hidden layers. If you ask somebody what is layer 3 doing, he doesn't know. What he knows, that if you give a proper input, my system will give a proper output. The way we do not know how somebody is playing good cricket. We don't know. Tendulkar's son is not as good a batsman like Tendulkar. Now, why it's not? No doctor can tell you why. Because of these kind of things. That's what we are trying to copy in machine learning. So, AI is the superset. Within AI, there is machine learning, and within machine learning, there is one method, deep learning. So this is the normal scenario most of you might be knowing. So I'm skipping. In machine learning, it can be supervised, it can be unsupervised, and it can be reinforced. Supervised, label data, direct feedback, and you can predict outcome. In unsupervised, the data is not labeled, no feedback is given. So how it works? It finds hidden structure, the correlation, and based on that, it can decide. And there is reinforcement learning, decision process, reward system, learned series of action. Like we humans do when we teach some in the class, a student is doing very good, he gets A+. Somebody doing bad, he gets D, C. So that's the reinforcement learning based on your thing. So if you can see if somebody is new, mechanism that can look at examples and produce generalization, that's supervised learning. Like spam detection system, you can label set up spams and not spam mails, and after that, coming from that email, it will automatically put into spam. Just teach them what is spam. So application can be object recognition, character recognition, spam detection, pattern recognition, speech recognition. As you can here see that duck, not duck, that's label data. And then you can have a model, and then you give a new, based on that it will say whether it's a duck or not. Supervised is easy. Now in unsupervised, techniques to find the patterns in data, so there is no labeled output. Find hidden correlation, it works on hidden correlation. So if you give these kind of data, it will automatically say that these three are closer in terms of features and put it in one bracket. This is somewhat different, this is somewhat different. So now you have three clusters, and based on that, a new things if you put, it will say that it belongs to which cluster. So here clustering, density estimation, or statistical analysis are the applications. Reinforcement learning, let's see, here is a robot, here is a tap, and there some fire happens. So once it detects that fire has happened, where should it run? If it goes, ideally, if there is a human, it will not go to the fire. It will go to the water. Then with water, it will go to the fire. So now you want to train the machine. So you allow it to take a random decision. If it goes to the fire, you can say no. You are given a penalty. So from the next time, he learns, okay, it's bad. Next time, avoid it. So this is the way you can implement reinforcement learning. So that's where automated cars, robotics, game playing, humanoids, skill learning. So these are some of the applications. So we have seen the AI, we have seen the IoT. Now, how improved healthcare? Devices gather and share information directly. Data streams are collected, recorded, and analyzed faster and accurately. Faster means in real time. Results in minimizing patient-provider gap, improved patient engagement, identifying patient needs, and provide personalized services, improved decision-making, reduction in healthcare cost. I will tell you my own experience. I went with my father to Medanta, Delhi, one of the best hospitals in India, not only in India, one of the best in the world. It took me 3 hours to get my father admitted. The kind of, so many paperwork, this, that. So these kind of things can be drastically reduced if we automate things. So the key entities in the healthcare ecosystem, one is the patient, one is the doctor. But to bring them together, you need providers. And these providers may not be hospital alone, the insurance people, the payment people, the ambulance people, all things, so many services comes here. So as you can see this situation, this is the patient, here is the doctor, and here is a insurance company, the company which asks for annual premium. So today, what is the situation? Let's say we are two friends. I am in Patna, and let's say Dilip sir is at IIT Bhagalpur. We are friends. Now, our annual premium this year is same. Let's say 10,000 for him, 10,000 for me. For next 1 year, I sleep, eat so many, hotel foods, doesn't do any exercise. On the other hand, my friend Dilip ji, he's keeping himself fit, eating healthy, every readings are normal. Why should we both pay similar premium next year? He should get the benefit of his life, his controlled life. So today it's not happening. There is no disconnect. You're paying premium, whatever you're, but tomorrow what will happen? You will have wearable devices, and the data will not go only to the doctor, it will go to your insurance company also, and based on that data the company will say, no, Dilip ji will pay 10,000 only, but Prabhat Kumar has, he is not controlling himself, we are not going to take his risk, he needs to pay 20,000. So this is how these data, these wearable data devices. So one scenario. The other is you are getting accurate data. So the medicines prescribed to you is as per your need, as you will get real-time care. Today, what the doctor write 2 tablets daily. Now you're eating it for next 30 days. Nobody is seeing whether you require after 10 days or not. You will go again after 30 days, then the doctor will say, now stop it. But in the ideal situation, the data should go to him and correct him, like 1 tablet per day should happen after 15 days. But nobody knows. Even it is, if required 3 tablets per day should happen. So this is where IoT and AI can benefit. The third is, this patient may not be in the hospital. These facilities can be provided in home. So combine the benefit of home as well as the benefit of doctor. So clinical care, constantly monitoring, and through cloud analyzes data sent to caregivers. So these people may not be at the same place. Technology exists. We all, what is required is, today also in a village, they're not getting good doctor facility. But if we can make these kind of things, if some of you can plan these kind of projects, you will get government funding also. So remote patient monitoring, then you need to have implants. Implants may be connected to transceiver, and then through Wi-Fi it will go to cloud. And once it goes to cloud, the physician from US or UK or India, anybody can see your data, do proper diagnosis. So this is also, it's happening also. So, but it has still not reached to the village level. So with huge population, more devices, and then you will say it's very easy, just connect the devices. No, it's not easy. Once the volume increases, the capacity of the devices, the bandwidth capacity, the cloud capacity, everything needs to, even the programming, the application program which we have written will crash. Remember when your class 10 results come, what happens to the NIC server? It crashes because it's built for a particular load. People who are learning computer science, they will know there are type of testing like stress testing, load testing, where you test your code for these kind of loads. That comes into picture. So improved and timely care. I will a little bit hurry up. Another video, IoT for healthcare. Just see. Due to time, I've stopped it because it's showing similar setups. But try to understand. I know many of my young friends will be thinking, I will remove the barcode device from the cloth and it won't be detected. But normally it's hidden. Now, newer barcode readers are very small in size. And it's not only in hospital, even if you go on a vacation on a big cruise ships, if they won't give you a barcode reader on your hand, you will not be in a position to come back to your room. It's so similar that it's chances that you will find it difficult to locate your own position. Or if your family members go at one go for an event and another go for swimming, it will be difficult to meet. So if you have those kind of things, you can detect the position, location. So it's not easy. It's rather it's required. Just remember when few years earlier, people were not understanding what's the use of Google Map. Now you go to a big city and see 4 highways, starting from the same place, either to go left or right or straight, which will go where you don't know. So you require Google Map. Similarly, you require these kind of things in coming future. Now, coming back to medical sensors. Previously, we had seen some other type of sensors. Now here you see what kind of medical sensors we are coming. In 2012 itself, they have a tooth enamel biosensors. 2012 contact lens biosensor. They were costly and the size was an issue as well as the cost was an issue. But now the cost, size and functionality all have improved. There was a colorimeter sweat biosensor developed in 2017. Then microfluid biosensors in 17. So as you can see, the list is endless and the research is still going on. So it's not that the biomedical sensors are not there. I have seen many of my friends in Patna, they are wearing this glucose meter. I think I have that somewhere. So a list of sensors are there. I'm just skipping to show you something more interesting. So chemical binding. So this is the glucose monitoring sensor that is being used in most of the hospitals today. And it is connected, it can be connected to smartwatch, Google and Apple. Apple is a way ahead. They will very soon have a smartwatch which can measure sugar reading. And whenever that comes, the cell will be at least 10 times. So we are talking about smart pill bottle, pouches. Old people, they forget. So they do not remember whether they have taken. So the bottle itself will remember whether the pill has been taken today or not. So these kind of things are also there. Just say this glucose monitoring system presently in use.
Sarah can take her first glucose reading 1 hour after the sensor has been activated. If the reader is off, just press the blue home button to turn it on. It's the only button. All other actions are done on the touchscreen. Hold the reader within 1.5 inches of your sensor to scan it. You can scan right through your clothes. When you scan, the reader displays your current glucose reading and a glucose trend arrow, which tells you the direction your glucose is going and how quickly or slowly it's changing. The glucose graph will display the most current 8 hours of data. If Sarah taps the pencil icon, she can add notes about food, exercise, or an insulin dose. Instead of finger sticks, Sarah can now simply scan her sensor to get her glucose reading, plus a lot more information. You can do it without finger sticks.
It's not only about the reading, that's what I want to tell you. let's say that device has a 14-day reading, 2 weeks reading. At the same time, you can have your 2-way reading of the food you have taken, the sleep you have done, the time spent with the friends. So now with that reading, what you can correlate is doing what your body is getting better, So that information which will be made to you particularly, it may be different for you than your friend, than your father, than your brother. Every human being has a different body, and the medicines of future will be according to your body. It's not that everybody, when you have headache, you take one medicine. No, it depends on whose body what. So these kind of sugar reading will tell that eating, let's say, how much roti one can eat. It may vary from body to body. Whether you can drink cold drink at what time. It is quite possible that when you are running in the afternoon, you can take some good food or a sugar. But in the evening, you are having some problem. So that reading and your life pattern, once together, a lot of data will come. With proper analytics, you can find better customized solution. So that's the future. Now, as one see, we are talking about more wearable devices. What will happen? You can monitor more, context-aware measurements, daily activities, social interactions, assist more. That means actuator, simulator, the insulin used for controlling sugar will be released not as a decided by doctor. It will be released automatically as per body need. If today I'm exercising more, I don't need insulin from outside. Tomorrow I'm sleeping more, maybe I need a bit more this insulin. But that is not happening now. So the drugs has its own disadvantage. So IoT with biomedical engineering has a potential to change completely. Let's see the vision of Microsoft for healthcare.
It's the symbiotic relationship between the human and machine that brings the magic of AI to medicine in a meaningful way.
Now we have the tools to make a huge difference to human life. Cancer research is increasingly powered by data. Those data remain siloed across institutions.
We're creating a data ecosystem that allows people to share data and making sure that we're doing that in a way that still maintains the privacy of the patients.
With the power of AI, we can go after the unknown. And I can guarantee that we'll find something that nobody expected.
Sudden-Fender syndrome scares every mother and father, and it is a problem we have to change. The collaboration with Microsoft AI for Health will help to start this next step of our discovery. Our data show very convincingly clear correlation between smoking and SIDS, and just changing behavior can save children's lives. You cannot measure the benefit of that.
It's a sad day when the patient comes in and I can't impact them.
Through AI for Health, we will be building an AI solution that can autonomously diagnose diabetic retinopathy.
With the portable camera, I can take healthcare to the patients who would not be able to come to us. You can look right here.
Going forward, we can address the 500 million patients that are out there and disrupt this disease. AI for Health and IRIS together can have that impact.
Today, there are 200,000 leprosy patients diagnosed every year. If you catch it in the stage of a skin lesion, you can cure the person. We are teaching an AI algorithm to recognize leprosy in an image of a skin lesion.
With AI, we can help patients help themselves to get to the right experts at the right time. If you can help a child to not lose their fingers, that means everything.
Innovation comes from bringing different perspectives together. And what an amazing partnership this is for all of us.
When you see that you can make a big impact on somebody's life, that's the greatest thing ever.
We can help eliminate the oldest disease known to man and make history. That's how we want to contribute to the world.
So I think I have exceeded my time. Dilipji, what is the situation?
Sir, yes, sir, time, sir. Maybe, sir, 10 minutes you may take, sir.
I think I have already, the last slide has told them what is. So today we are talking about the digital nervous system And as you can see, this is the analogy between biological nervous system and the digital nervous system. And there are some potential barriers. Just you see this slide, and then we will conclude the future of healthcare.
In the decades ahead, healthcare will undergo dramatic transformations. Medicine will become more precise. Value will shape care delivery. Patients will become empowered consumers. And digitalization will transform every facet of healthcare. Patients will have a digital twin, a customized computational model of themselves, enabling Dr. Clive to anticipate illness, guide therapy options, and predict outcomes of procedures. Expanding precision medicine will enable radiologists to make highly specific diagnoses for Stephen without unwarranted variations. AI-powered decision models, fed by vast population health data, will improve diagnostic accuracy. Healthcare will become anticipatory, organized around Paula's medical conditions, and available around the clock, transforming care delivery. Multidisciplinary, highly productive care teams structured around patients and their needs will collaboratively deliver the full cycle of care. All interactions with John will become convenient, personalized, and compassionate, improving patient experience. Supported by real-time monitoring and guidance, John will become more empowered and have physical and virtual access to care when and where he needs it. At Siemens Healthineers, we are enabling healthcare providers to increase value, shaping the future of healthcare.
Some research challenges are there, but straight way to thank you. Thanks for your patient learning. If you have any question.
Any questions? So should I conclude it? Any question? Please ask.
Just try to make simple programs more towards the society, and you will benefit. And lots of jobs. You know, I've been to many countries, and the situation is computer science has lots of jobs. Don't worry about the layoffs.
Thank you so much, sir, for your efforts to enrich our minds with your very informative expert lecture. You explained about AI-enabled IoT for biomedical engineering. You informed us about biomedical engineering, healthcare sector, and its market segment. You taught us about IoT, its architecture, its 3C cloud, communicate and control. You made us aware about sensor, its type, microcontroller. You showed was very informative and showed us about our future with IoT and AI application in our daily life. Then you went on to explain about human's memory, short-term, long-term, and sensor memory, and goals of AI, Turing test, applications of AI. You then informed us about machine learning and deep learning, supervised, unsupervised, and reinforcement learning. Then you beautifully explained how both IoT and AI can change the healthcare ecosystem, and also showed an awesome videos including Microsoft AI program for healthcare and digital nervous system. I am sure our participants have attained a better understanding about all these topics. Thank you again, sir, for taking out your valuable time to impart us with your knowledge. Thank you,
Dr. Dilip. Thanks.
Just wait for 5 minutes. No need to be leave it. Our next resource person will be online by 4:40. Okay? Just take a break. Our next resource person have come online. So a very hearty welcome to our next speaker, Dr. Silparna Saha ma'am. We are very delighted to have your presence in our STC. Thank you for providing your valuable time for this STC. I'm going to introduce about ma'am. Dr. Silparna Saha received MPhil in Computer Science from ISI Kolkata, India in 2005 and 2011 respectively. She is currently an Associate Professor and Head of the Department of Computer Science and Engineering, IIT Patna, India. She has authored or co-authored more than 350 papers. Her current research interests include deep learning, natural language processing, machine learning, information extraction, text mining, bioinformatics, multi-objective optimization. Stanford University in survey also listed her as one of the top 2% of scientists in AI with more than 5 published papers. She is the associate editor of several reputed journals, including IEEE Transaction of Computational Social System, IEEE ASM Transaction of Computational Biology and Bioinformatics. Plus one pattern recognition letter, expert system with application, neurocomputing, ASM transaction on Asian and low resource language information processing, etc. Her current H5 index is 35 and total citation count of her paper is more than 6,854. She is the recipient of several awards and fellowships, including the ACRA Women in Excellence Award 2018, Google Indian Women in Engineering Award 2008, Nasi Young Scientist Platinum Jubilee Award for the year 2016 in the field of electronics, computer science, and engineering. ASIA AA Rashid Memorial Medal from ISI Kolkata, India, for being adjudged with the first examination in computer science in the year 2005, Humboldt Research Fellowship 2015, CNRS Fellowship. Welcome, ma'am. Over to you, ma'am. Please.
Yeah, thank you, Dr. Dilip, for this invitation. So, am I audible? Hello?
Yes, ma'am. Audible, ma'am.
Yeah,
Audible.
yeah. And my screen is visible?
Yes, ma'am.
Yeah. So, a very good afternoon to all participants, and many thanks, Dr. Dilip, for this invitation. So basically, today I will talk about AI ML applications in digital health. So I am Dr. Sriparna Saha, currently working as an associate professor and head of the Department of Computer Science and Engineering, Indian Institute of Technology, Patna, India. And this is my web page. And my email addresses are sriparna@iitp.ac.in or sriparna.saha@gmail.com. So you can email me regarding any particular concern or any particular topic. Like if you have any particular question, you can ask me anytime. Otherwise, you can also email me, and you can visit my webpage because all the publications related to this particular area are listed in my webpage. So let me basically in today's talk, I will discuss about some recent applications of AI and machine learning in solving some problems related to digital health. So mostly I will be discussing about two approaches. One is the development of some virtual doctor or the conversational agents. So basically how we can develop some conversational agents with the help of deep learning, machine learning techniques. And also I will discuss about the development of some motivational chatbot. So what is the artificial intelligence? So basically artificial intelligence is a very popular branch of computer science. So that concerns with the building of intelligent smart machines capable of performing intelligent tasks. So basically by using the artificial intelligence tools and techniques, we can make a machine intelligent enough. So a machine can behave like a human being with the use of AI. So with rapid advancements in deep learning and machine learning, the tech industry is transforming radically. So basically, by the use of the AI technique, we are transforming the nature of work, learning and learning to work. So AI is having many different paradigms, and machine learning and deep learning are two important paradigms under AI or the artificial intelligence. So AI can be used in different sectors. So you can select any particular sector of society and you can see an application of AI there. So like you suppose in the human resource management, in fraud detection, so whether a particular transaction is fraudulent or a particular customer is fraudulent or not, that can be easily decided by the AI based technique. Or the knowledge creation or the research and development, then pricing and promotion, customer insight, risk management and analytics, customer services, real-time operation management. So in every sector, you can see an application of AI. So like in predictive analysis, AI is having an application. Then the customer experience. So if you want to improve the customer experience, we need to utilize the AI. So you know that predicting some cost or predicting the market value of a particular product, we can utilize the AI-based technique. So AI has applications in almost all the sectors of the society. So now let me discuss about the, what do we mean by the virtual assistants. So basically, the virtual assistants are called the chatbots. So these chatbots are very popular nowadays because in our day-to-day life, we are using the Alexa or the Siri. So this Alexa or Siri are examples of the chatbots. And this Alexa and Siri are basically some kind of personal assistants. So we can ask for any kind of service from the Alexa. We can give some instructions to Alexa and Alexa can execute it. So we can ask for the weather update from the Alexa, or we can ask for the play music in Alexa, and Alexa is always a personal assistant. So Alexa is following the instructions given to it. So, there are different types of virtual assistants. There are some virtual agents. There is a personal assistant. There is a virtual counselor. There is a diagnosis agent. Like the virtual assistant can also be used in the medical domain. And that is basically the diagnosis assistant. Then, the virtual agent can also be used in the customer care as a customer care representative. Like we know that in many banking sectors, or any customer care representatives are basically replaced by the chatbots. So in customer service center, chatbots are heavily used. Then nowadays chatbots are also used as a sales agent. So basically, that in order to sell a particular product, and the sales agent are very intelligent enough, because selling a product is very, there are much intelligence is needed. Like you need to have the persuasion and the persuasion and also the negotiation capabilities. Like suppose a user wants to purchase a product, so the user first gives the requirement basically gives the requirements or the specifications, and then the sales agent used to see the requirements and the specifications, and they used to search in the database. Now in the database, maybe some products are matching, some are not matching. So maybe in order to sell a particular product, the sales agent used to pursue the user. So this persuasion is having several strategies. So like we can have the persona based persuasion. So if we know that the person is a good photographer, then the persuasion can be done based on the camera quality. If the sales agent knows that the person is very emotional, then maybe it can utilize some emotional appeal. Or if already the sales agent knows that the customer is very logical, then some logical reasoning can be used for the persuasion. So the persuasion can be of different types. So there are different types of persuasion strategies, and any of these strategies can be utilized for the persuasion purpose. And once the product is fixed, the next is the negotiation. So negotiation can be done on the cost. So basically, the sales agent and the customer can negotiate on the price. So this way, the virtual agent is having many applications in almost every sector of the society. So virtual assistants, so basically humans are interacting with the computers, and they are trying to solve some particular task. So these virtual assistants are also called the task-oriented virtual assistant. So there are several chatbots or the virtual assistants, and they used to interact with the humans, and that way they are called the task-oriented virtual assistant. So there is a concept called the human-inspired learning. So learn a task more effectively and quickly if guided by an experienced individual or the learning guidelines. So basically, you know that there is a human behavior or the experience. So data, the data is basically carrying this experience, and then with the help of the data, we are teaching the machine learning, deep learning models, and as a result, the virtual assistant is basically built. So basically, data is the knowledge here, or data is the experience here. So data is the teacher, and basically data teaches the machine learning, deep learning model, and that way the virtual assistant is basically developed. So you know that this virtual assistant is intelligent enough. It can successfully to solve a particular task, and also it can accomplish the task in less time, and also it can learn from the failed attempts. So basically, you know, the virtual assistant is very intelligent enough, so it can successfully accomplish a particular task, or it can accomplish the task in less time, or it can also learn from the failed attempts. So this way, virtual assistants are very intelligent. So this is the overall diagram of the virtual assistants or the dialogue systems. So you can see suppose the user is uttering a utterance, user is saying something. Now there is an automatic speech recognition module. So this automatic speech recognition module is basically translating the speech signal into a text signal. So basically it is translating the speech into text, and then this text is basically analyzed further. So there are two modules, spoken language understanding module and the dialogue state tracking module. So spoken language understanding module's task is to understand the user's intention or to extract the important information from the user's utterance. So here the input is a text, or the, after the speech to text, we are getting the speech version of the text, and that is given as an input to the spoken language understanding module. And the spoken language understanding module is having three sub-modules: dialogue act classification, intent detection, and the slot filling. So dialogue act classification means to identify the communicative intention of the speaker, like whether the speaker is asking a question, or it is an open statement, or it is a command, or it is a greeting. So the category of the utterance is called the dialogue act classification. Then comes the intent. So intent means to identify the user's intention. So what the user is trying to say, what is the intention behind the utterance. And the slots are the important information which are present in the user's utterance. So all these, all these things are identified from the, from the textual utterance, and that gives us a state information, and that is called the dialogue state tracking. So all this information, the dialogue act classification, the intents, and the slot values are given as a state to the dialogue state tracking. And now it is given as a information of the dialogue policy. So dialogue policy is a reinforcement learning based agent. So it basically maps the state into action. So basically, in reinforcement learning, it is a Markov decision process where there is a set of states, there is a set of actions, and a policy basically maps the states into action. So this mapping is done by the dialogue policy or the dialogue management. So it is a reinforcement learning based agent, and it basically maximizes the rewards. So for each action, for each state, when an action is taken, there is a reward or there is a penalty. So accordingly, basically, accordingly, the dialogue policy is basically optimized. And finally, there is a natural language generation module. So this natural language generation module basically, translates the, like this dialogue policy is taking an action, and this action is translated into system response by the natural language generation module. So basically, dialogue policy is taking and mapping a state into an action, and this action is translated into system response by the natural language generation module. And finally, there is a text-to-speech module, which is translating the system response into the speech signal. So this is the overall diagram of the end-to-end dialogue system. So user is, saying something, and then it is translated into text. Then all the processing are done on text. And finally, again, text is translated into speech to give the response to the user. So this is the overall framework of end-to-end dialogue system. So now, what is the need of what is the automatic disease diagnosis? So you know the disease diagnosis is the primary and the crucial stage of any medical treatment process. And if you know that nowadays telemedicine facilities are becoming very popular, and especially in the rural India, where the number of ratio between the doctors and the patients is very alarming. So there are very less number of doctors compared to the patients. So the world falls short of 7.2 million medical workers, 30 millions by 2030. So most of the countries across the globe have only 0.01% to 0.1% doctors. A survey done by WHO shows 35% US adults had utilized self-diagnosis tools before consulting with the doctors. So basically, you know, the US adults are mostly mostly using the, you know, that this the internet for diagnosing the some diseases. They are searching their symptoms in the internet, and accordingly they are taking some decisions. So basically, the telemedicine or the, you know, the internet, the online medicine are becoming very popular. So the idea is that can we develop a virtual assistant which can perform the symptom investigation. So thus efficient time utilization of doctors and early diagnosis are two key motivations for disease diagnosis assistant. So here you can see, like, suppose the patient is visiting a hospital and the patient is initially having a self-report. So in the self-report, patient has mentioned about his or her own set of symptoms that he or she is suffering from. Now, based on this self-report, the receptionist can guide that patient to a particular department. So in big hospitals, there are several departments like eye or the, you know, the gynecologist or the ENT. There are several departments in a particular hospital, and based on the self-report, the receptionist used to guide the patient to a particular department. And now, you know, in the department there are many senior doctors and there are some junior doctors. So these junior doctors are responsible for the symptom investigation. So they used to ask about some further symptoms, and then they used to generate a report, and this report is basically is given to the senior doctor, and the senior doctor basically prescribed a medicine, basically diagnose the disease and then prescribe a medicine. So basically you can see, like, this is the this is basically virtual doctor. So like it is doing the symptom investigation. So depending on the self report, it is asking some additional symptoms from the patient, and then the report is generated, and this report is given to the senior doctor, and based on this report the senior doctor is prescribing the, you know, the medicine, and also, you know, the diagnose the diseases. So basically, our task is not to replace the doctors, but to develop a AI-based assistant which can help the doctors. Like we can basically save some time of the doctor, and which can help in symptom investigation. So you know that this is the idea. Like, you know, the patient is, hi, I have been suffering from fever for a few days. Also, something happened in my mouth. Please see this. So now the diagnosis assistant is asking, did you recently vomit? Yes, I vomited yesterday. So do you have eye pain? The patient is saying, yes, I am feeling so. Now, have you observed any skin rash in your body? So now here you can see the patient is not able to express. Patient is not having the information about some symptoms like skin rash. Maybe the patient is not aware of the name. So patient can simply show some images. Like patient is showing some image of, you know, of his hand. And now from the image, maybe the agent can easily extract the information that this is the information about the skin rash. So I am not sure, but please see this. So basically, you know, then from the image, the patient will understand that yes, basically this is the image of a skin rash. So finally, report is generated. The patient suffers from the following symptoms: fever, mouth ulcer, vomiting, eye pain, and skin rash. The most likely disease is erythema multiforme. The images are shown below. This way, a report is being generated. So this, that report is basically being generated, and then, you know, this report is, and this report Hello. Yeah, and then yes. Any question? Satyajit Azhar?
Yes, ma'am. I have one question. So, how much we can trust, ma'am, this virtual assistant in diagnosing and all in healthcare? Because the
Yeah,
data we
so
don't know how they are trained enough. The training data set.
yeah, correct. So I will show you. I will show you the accuracy or the the prediction accuracy of this. So you can see these are not very accurate, but as I told you that as the final decision is taken by the doctors only, so it's a simply aid or a help to the doctor. It is simply saving some time of the doctors. So that's why we can rely on this. And if there is an error, because we are still we build a preliminary model and we are now working on how to improve this further. So basically data set is a big challenge because getting a medical data set of this kind is very difficult. So basically we are how we are developing the data set, I will tell you. So we in our lab only we are preparing this data set with the help of a doctor. So we have a collaboration with AIMS Rishikesh. So in AIMS Rishikesh there is a Dr. Meenakshi. So she is helping us in developing the doctor. She is only validating the outputs of this virtual doctor. So yes, so I will mention this in my slides. Okay. So but yes, we are still working on this. So some preliminary prototypes are already built, and now we are working on this to improve this further.
Okay, ma'am. Ma'am, if doctors are biased, then how they are going to label the data set? I mean.
Yeah, so biasness, so we assume the doctors are not biased because here
I mean,
it is
if their
only
knowledge is somehow biased, then
then there is a problem. Yes, that is an issue. But that's why we are annotating using 3 doctors. Okay, not only a single doctor, but there are 3 doctors. So 3 doctors are in parallel. They are basically annotating the data, and then we are taking the majority voting. Okay, so this annotation is done based on 3 doctors.
yeah.
So
Okay,
that way, if there will be a biasness by a single doctor, maybe as we are considering 3 doctors, it will be overcome.
Okay, thank you, ma'am.
Yeah. So basically, this is the kind of prototype that we have developed. So we developed this kind of diagnosis assistant. So it's simply a kind of a helper to the doctor. So it is helping the doctor in the symptom investigation. And as you see, this is called the multimodal information processing because now the patients can express their symptoms not through text but also through the images. Like in some cases, the patient is expressing the symptom through text, like I vomited yesterday. This is a textual representation of the symptom. But in some cases, it is also he or she is also showing some images. And from the images also, now the agent can easily understand, the assistant can easily extract the symptom information from the images. So this way, this is a, that this way, this is a kind of a multimodal information processing. So one of my Abhishek Tiwari is my PhD student. So basically, he got the PMRF, the Prime Minister Research Fellowship. Fellowship. This is a very prestigious fellowship. So a student can avail this fellowship, and then he can get a stipend of 75,000 rupees per month. And he got selected for this fellowship for this particular project, the virtual doctor development of some virtual doctor. And he is basically working on this problem statement. And as you know that developing a virtual doctor is not so easy. As I mentioned, that data set creation is a major part because there was not any multimodal data set existing for this particular domain. So we created our own multimodal data set. And then there are many problem statements related to this. One is that how can we basically, this virtual doctor is not having any medical knowledge. So how can we infuse some medical knowledge into this? So for that, we have utilized a knowledge graph. So this knowledge graph is having all information about the symptoms and the diseases. So a disease is having multiple symptoms, and then symptoms are also connected with the diseases. So all this information are basically done with the help of the with the help of this knowledge graph. So by using the knowledge graph, we are trying to infuse the medical knowledge into the virtual assistant. And also when you are interpreting a particular symptom, like when suppose user is showing an image and you need to understand the symptom information present in the image, that time context plays a very major role. So in which context the patient is showing the image, that is very important. And we are basically trying to develop some context aware the disease diagnosis assistant. So this disease diagnosis assistant is trying to understand the symptom information based on the context. So then there is another task, symptoms are known by their companies. So basically what happens is that men are known by their company if it keeps. So basically you know that when we are, some symptoms are very common, like cold, cough, fever, these are very common symptoms. But when they are associated with some other symptoms, then we can easily understand the disease. Because cold, cough, fever, these are very common symptoms. But when they are associated with some other symptoms, then we can easily understand the disease name. Then you know this multimodal automatic disease diagnosis, because in some cases, as we are dealing with the patients from the rural India, and there are many uneducated patients, maybe they are not aware of the many of the symptom names. Maybe they are not aware of the medical terms of the symptoms, but they can simply show the image signs of the symptoms, like the mouth ulcer, skin rash, or red eye. So the names of the symptoms may not be known to the common people of the society. So maybe they can simply show some images, and if the virtual assistant can extract the symptom name from the images, then that will be of very much use. So basically we are developing some multimodal automatic disease diagnosis system. And the fourth is basically learning from failures. So you know that the doctors, the real life doctors, always learn from the failures. So you know you have to develop some diagnosis assistant that also learns from the unsuccessful diagnosis. So like if there is an unsuccessful diagnosis, then you know the doctors used to learn from the failures. Similarly, humans learn a task through both successful and unsuccessful attempts in real life. So basically, can we somehow develop a virtual assistant which can also learn from the failures? So basically so that it can keep on learning the new things. So these are some four problem statements that we have worked on. So let me now discuss about the first problem statement, a knowledge-infused, context-driven dialogue agent for disease diagnosis using hierarchical reinforcement learning. So basically you can understand that the task is you have a set of symptoms. Maybe you have already asked about few symptoms from the patients. And now based on these symptoms, you have to understand the disease. So, you know, it's a very exponential problem statement, because if you have n number of symptoms, then the possible number of cases will be to the power n minus 1. Either a symptom can be absent or symptom can be present. So now we have to, you know, map this information to a particular disease. So we have to emphasize the need of knowledge-aware, experience-guided symptom investigation. So in real life, doctors usually do the opposite. So when a patient visits the doctor, based on the self-reported symptoms, doctors assume some disease, and then the doctor does some symptom investigation just to basically make sure that yes, that particular disease is correct. So basically, it follows a backtrack path. So based on the self-report, it assumes some disease, and then it follows follows the backtracking, like it in order to confirm this particular disease, it asks for some additional symptom information from the patient, and if the patient basically confirms those symptoms, then that particular disease is that it says that the patient is suffering from the particular disease. So you know that these hypothesize a set of candidate diseases depending on informed symptoms, current context, and first inspect symptoms of candidate diseases. So this is also called the symptom exploration and exploitation problem. So basically, we developed a knowledge infused. So as I mentioned, this virtual assistant is not having any medical knowledge. So we have to somehow infuse the medical knowledge into a virtual assistant, and then that can only be done with the help of some knowledge graph. So there is a medical knowledge graph is existing. So this medical knowledge graph is having information about all symptoms and all the diseases. So a disease can have multiple symptoms, and this knowledge graph is having information about all the diseases and all the symptoms. So a novel knowledge infused, context driven, task oriented virtual agent we are developing for automatic disease diagnosis using hierarchical reinforcement learning. So we also developed a hierarchical disease classifier So this disease classifier first identifies the department name, because you know that as I mentioned, for a particular department there are several diseases. Like for the eye department there are some diseases. For the gynecologist there are some diseases. For the heart there are some diseases. So we need to first identify the department name, and then for a particular department we can go for the fine grained analysis, and we can somehow predict the disease name. So basically we developed this hierarchical disease classifier, and we have shown a huge improvement over the current state of the art model. So diagnosis success rate is improved by 7%. So this is our overall architecture. So this master is nothing but a department, basically our department classifier. So basically first, this is a receptionist. It behaves like a receptionist. So first, the receptionist used to decide about the departments, and then each department is following its own policy. So there are some higher level policy and there are some lower level policies. So now there is a hierarchical disease classifier. So the hierarchical disease classifier is first identifying the department name, and then for each department there are some specific diseases. So then there is a potential candidate module. So this potential candidate module is basically working as a knowledge graph. So this pathogen is nothing but a knowledge graph. So it is giving the enough context, and accordingly the disease is basically, it is giving some clues to the dialogue manager that these are the potential symptoms, and accordingly, some symptom information can be asked from the user. So this is the overall diagram. So basically it utilizes the deep learning and also the reinforcement learning. So by using the reinforcement learning, we are basically identifying the correct action, and that action is translated into system response. So so basically we have utilized these 4 data sets. So basically we have not worked with the Chinese version. So there are 4 data sets in this orthopedic diagnosis system, RD, DX, which are in Chinese languages. And there are 2 English data sets, SD and the synthetic data set and the MDD. So these 2 data sets are written in English. So in SD data set, there are 30,000 users and 90 diseases and 266 symptoms. And the diseases are dengue, fever, diabetic, etc. And symptoms are sore throat, fever, ankle pain, shoulder cramps, etc. And the MDD is the medical data set. Here there are 1912 number of user goals, and number of diseases are 12. And then the number of symptoms of 118. So that and here the diseases are basically this esophagitis, enteritis, asthma, etc. And the symptoms are dizziness, chest lightness, burning sensation behind the chest, breastbone, etc. So each sample in the dataset is having this kind of loop. There is a consult ID, there is a disease tag, there is a group ID, and then there is a goal, disease, and then there is a explicit informed slots. There is a implicit informed slots. So this is the each sample of the dataset looks like this. So you can see these are the learning curves. So we develop different versions of the proposed approach. So knowledge infused, the system is knowledge infused our investigation. The knowledge infused context driven hierarchical disease classifier, and also we have shown that we have done an ablation study, like what will happen if we remove the knowledge part there, what will happen if we remove the hierarchical disease classification from there. So these are the plots of the success rate. So you can see, like that knowledge infused hierarchical disease classifier is achieving the highest success rate, and also the dialogue length is also limited, and it is also having the highest average match rate and the highest symptom rate, basically success rate. So basically that this way we can show that these curves demonstrate the utility of the knowledge graph and also the utility of the hierarchical disease classifier. So you can see these are some results. We have done comparative study with the existing techniques. So we have compared our approach with the several existing approaches with respect to the success rate, dialogue length, average matching rate, SIR and the disease classification accuracy. So currently we are getting the accuracy of basically that 59.75%, which is not very high. This is on the SD data set, and for the MD data set we are getting the accuracy of 81.79%. So this way we are getting around 80% accuracy. So MD data set is having less number of diseases, and SD data set is having more number of diseases. So that we also did an ablation study, and we have shown that our proposed approach achieves the highest disease classification accuracy and also the other highest scores in the other metrics. So these are some results. That these are the disease endometrial hyperplastia. So now there is a self-report virginal bleeding after menopause. Now there are some implicit symptoms. So you can see this is a conversation. So the proposed model accomplishes significant improvement over the current state-of-the-art method, which firmly establishes the efficacy of doctor's diagnosis method inspired KICD diagnosis approach. So we also developed a hierarchical disease classifier, which is giving us the accuracy of around 49.74%. And this hierarchical disease classifier lacks negative symptom information. So next, we have also worked on the other problem statements, like, symptoms are known by their companies, towards developing a virtual diagnosis assistant with association-guided symptom investigation. So basically, that we are developing some association-guided symptom investigation where symptoms are known by their companies. So condition induces various effects, and these effects collectively represent the cause. So a word is known by the company it keeps. Similarly, symptoms also exhibit the association property. One symptom may strongly suggest other symptoms' existence or the non-existence. So we have investigated the role of symptom association in diagnosis process and proposes a novel association-guided symptom investigation incorporated diagnosis assistant. So this is our proposal. So basically, there is a module that we are developing a graph. So this graph is developed based where each node is a symptom, and we are trying to measure the association between two symptoms. So in how many cases two symptoms are co-occurring? For how many diseases these two symptoms are co-occurring? And from this association, from this graph, there is an association module which is giving us some association score. So basically, if suppose already user has asked for what there is a current requested symptom, now based on this current requested symptom, we are identifying the K other symptoms which are highly associated with the current symptom. And then there is a recommendation module. So this recommendation module will give this K number of relevant symptoms to the lower level policy. And the lower level policy can basically select one of the symptoms from this K number of symptoms. And then there is an association module, so which will give us a reward. So if suppose if the reward basically depends on the association score. So if suppose the lower level policy has asked for a lower level policy has asked for a particular symptom, and that symptom is very much related to the current requested symptom, then there is a reward based on the association score. So basically, that this is the architecture of the association guided symptom investigation and diagnosis dialogue system. So, here also we are following a hierarchical policy. The controller is a higher level policy, which is the kind of receptionist. And then the receptionist is invoking any of the departments. And these departments are basically, that there is a diagnosis state tracker, which is tracking the diagnosis state. And then there is a patient, and there is a disease classifier, which is doing the hierarchical disease classification. So now the novelty is this graph. So this graph is drawn based on the data set. From the data set, we collected the frequency of co-occurrence between two symptoms, and according to the age weight is calculated. And based on the age weight, the recommendation module is giving the K recommendations of the next set of symptoms, and also the reward is calculated. So if a particular symptom is asked, which is very much correlated with the current symptom, then there will be more reward. Otherwise, there will be a penalty. So we have shown the results on the two datasets, English datasets, And you can see that our proposed approach is having the diagnosis success rate of 55.76%. And in another major objective is that we cannot keep on asking irrelevant symptom information to the patients. Then the patients will get irritated. So basically, one objective is to minimize the dialogue length also. So basically, minimal number of dialogues, we have to do the appropriate symptom investigation. Then there is a average matching rate, and also the disease classification accuracy. So we are getting the disease classification accuracy of 56.16%. So yeah, you can see the results that the proposed association criteria symptom investigation and disease diagnosis outperforms all non-association guided baselines in the state-of-the-art model. So indeed, symptoms are highly, like this association information is helpful. Like when we are considering the association information between symptoms, then that is helping us in predicting the correct disease. So now you know that the next work emphasizes that all symptoms of a disease are not equally important. So basically, we have to do some selection of the important symptoms. Like in the machine learning algorithms, feature selection plays a very important role. So all the features are not important for developing a machine learning classifier. So we have to carefully do a symptom, feature selection. So similarly, a disease may have many symptoms, but they are not all equally essential or distinctive to the disease. So doctors usually diagnose patients by inspecting only a few symptoms, despite the fact that the diagnosed disease has several symptoms. So basically, a disease may have many symptoms, but we have to carefully select a subset of symptoms based on which the prediction or the diagnosis can be done. So we have to investigate the role of symptom importance in the disease diagnosis process, and we propose and build a novel symptom importance aware diagnosis framework using feature selection and the hierarchical reinforcement learning. So here, this is our novelty. So other parts remain very similar. Like there is a master, which is the higher level policy, because we are developing a hierarchical reinforcement learning based policy. So master will behave like a department, like the receptionist, which will guide the patient to a particular department. And each department is having its own lower level policies. And the departments will basically ask for the further symptoms. So now, but basically there is a feature assessment procedure. So this feature assessment module will basically assess the importance of individual features or the individual symptoms, and then a set of symptoms will be selected, and these symptoms will only participate in disease classification. So basically, there are some common symptoms like the fever, cough, cold, which are very common across all the diseases. And maybe these symptoms are not important for predicting the diseases of all types of diseases. So we need to select a subset of the symptoms, and then based on the symptoms only we have to predict the disease. So basically, this is the task here. So we are doing a symptom assessment module, and by using the symptom assessment module, we are selecting a subset of symptoms, and based on the symptoms only the disease classification is done. So here also you can see that this is the result of our approach. So we have done different types of feature selections, and our feature selection finally we are getting 240 number of symptoms and the highest accuracy of 80.6%. And with this, when we are developing the model, our success rate is 52.50%, and we are taking 10 point minimum in an average 10.30 number of dialogues, average matching rate of 11.24, and also disease classification accuracy of 51.78%. So here you can see like one example, like, hi, I am feeling headache since few days. Can you please tell what might be the problem? So then the dialogue agent is saying, hi, I am here to help you. Are you also feeling anxiety and nervousness? So the patient is saying, no, I don't think so. Agent is saying, great. Are you feeling dizziness? The patient is saying, no, I don't have dizziness issue. The agent is saying, do you feel nausea? The patient is saying, yes, I am feeling nausea. Agent is saying, yeah. Do you have also neck pain? Patient is saying, yes, I am feeling some neck pain since some days. Dialogue agent is saying, okay, you are most likely to have cerebral edema disease as per the symptoms. Patient is saying, okay, thanks for the assistance. Dialogue agent is saying, thank you. So these are the conversation ends. So basically, you can see that symptom importance our diagnosis model performance basically improves. So basically, we need to select some important symptoms, and based on those important symptoms only, we have to predict the disease. We should not consider all the diseases, all the symptoms, because some of the symptoms are very common across all the diseases. So before predicting the correct disease, we need to carefully select a subset of symptoms, and based on the symptoms only, we have to predict the disease. So we observe that the agent informs the right disease with only patient's self-reported symptoms, where patient's self-reported symptom is quite unique for its corresponding disease. So incorrect disease prediction, but the predicted disease belongs to the same group of actual disease. So in the next work, we have done multimodal automatic disease diagnosis assistance. So here, as I mentioned earlier also, like now the conversations may also contain some images. Like if suppose the patients are not aware of some symptom names, then patients can also show some images. And from the images also, the agent can easily extract the symptom information. So in real world, when we consult with doctors, we often report and describe our difficulties or symptoms with the visual aids. So basically, sometimes the patients have to report the symptoms using the images. And from the images only, we have to extract the symptom name. In fact, many people are unacquainted with several symptoms such as mouth ulcers, skin growth, etc. And they are not aware of the medical terms of these symptoms. So in those cases, they can simply show the symptoms to the signs. And from the sign information, the symptom name can be extracted. So we basically developed two modules: symptom image aided symptom investigation and diagnosis, and dialogue context aware symptom image identification. So we developed basically these two modules. So we developed a multimodal disease diagnosis virtual assistant using hierarchical reinforcement learning. And this multimodal diagnosis assistant can extract the is able to understand is able to extract the symptom information from not only the textual utterances but also from the images or the signs of the symptoms expressed by the patients. And also this basically we are given an image, we have to identify the symptom information. So this is basically context based, in which context the patient has shown the image. That is very important for proper symptom identification. So we are developing a context aware symptom image identification. So basically here the context is given as an input, and also the image is given as an input, and then the agent basically this module is extracting the symptom name from this image. So we are developing and when we started research in this particular area, we identified that there is no multimodal diagnosis dialogue data. So basically we also developed a multimodal diagnosis dialogue data for this very purpose. So this is the overall architecture. So many things are very common like the previous one. So there is a controller, which is the the receptionist, where there is a higher level policy. Now this the task of the higher level policy is to appropriately decide the departments. Now each department is having a lower level policy. And now basically there is a multimodal disease diagnosis state tracker. So this basically user is saying something. So user can either show in text or can either show in image. So that from the text also we are extracting the symptom information, like the symptom information like fever, etc. can be extracted from the text. And then the user can also show some images, and from the images also we can extract the symptom information. And then together we can provide this as a dialogue state tracking. And then this dialogue state tracker can be given to a disease classifier, and the disease classifier can predict the disease. And now that this diagnosis assistant, this virtual doctor is used for the basically the symptom investigation. So depending on the current set of symptoms, the agent is asking for the next symptom. So that and then that and basically it is by the use of the natural language generation module, the appropriate the action is translated into the response. So that this is the input that, hi, I have been suffering from fever for a few days. Also something happened in my mouth. Please see this. So here there is an image also. So from the image, from the we have to extract that this is the information about the mouth ulcer. And now there is a state tracking. So one fever is extracted from the text portion, and from the image we are extracting the symptom information, mouth ulcer, and these two are given as a state information. And now based on this state information, this controller policy will be invoked. Accordingly, the departments will also be in lower level policy will be invoked, and the lower level policy will be responsible for doing the symptom investigation. And finally, the report will be generated, and the report is that the patient is suffering from fever, mouth ulcer, vomiting, skin rash, and chorea. The most probable disease is erythema multiforme. Also, the patient's mouth image is shown below. And now this report can be given to the basically senior doctors, and the senior doctors can basically prescribe the medicine and also can diagnose the disease and verify the disease basically. So that this is our context aware image identification module. So like we are not only inputting the image but also the context. So in which context the user has shown the image information. So these two are given to this particular module. And here for the text portion, we are using the bar, and for the image, we are using the dense net. So features are extracted from the dense net, and from the from the context, we are passing through the clinical bio bar, and then we are concatenating the feature vectors, and then we are passing through the softmax, and accordingly basically the classification of the symptom is basically done. So the symptom information is basically extracted. So here, but there are two modalities. One is the text modality, and another is the image modality. So from the text modality, fever information is extracted, and from the image modality, this key and this basically cloudy vision is basically extracted. And then together we are trying to identify the symptom. So as I mentioned that when we started doing research in this. So, that when we started doing research in this particular domain, there was no dataset existing. So, the number of dialogues is 1500 and number of utterances is 6936. So, so basically these are the things that number of dialogues is 1500 and the number of utterances are 6936. And the utterance tags are intent, symptom, and the image information. And average dialogue length is 4.62. And there are only two. So basically, that the number of the average dialogue length is 4.62, and the number of intents are basically 2, and the number of diseases are 90, and the number of symptoms are 266, and the number of visual symptoms are 17 plus 3. So 17 are basically the textual symptoms, and 3 are basically visual symptoms. So basically, this is we identified 3 visual symptoms, and total number of symptom images is 1805, and number of multimodal utterances is 725. So this is our dataset statistics, and these are some new few multimodal symptoms. So skin irritation, mouth ulcer, skin growth, eye redness. These are some examples of the multimodal symptoms. So like this is an observed conversation for our dataset. Like, hi, I have been suffering from fever for a few days. Also something happened in my mouth. Please see this. So now the agent diagnosis assistant is asking, did you recently vomit? Yes, I vomited yesterday. Do you have eye pain? Yes, I am feeling so. Have you observed any skin rash in your body? I am not sure, but please see this. So basically he or she is showing some skin rash. So the patient suffers from the following symptoms: fever, mouth ulcer, vomiting, eye pain, skin rash. The most likely disease is erythema multiforme. The images are shown below. So this is an example of our dataset. And in our dataset, there are some multimodal symptoms, and also there are some textual symptoms. So basically, we talked with the AIMS Rishikesh Dr. Meenakshi, and with her help, we identified these 4 symptoms which can be expressed using images also. Skin irritation, mouth ulcer, skin growth, and the eye redness. So these are the results. So basically, these are the results of our, the symptom image classifier. So with the context window of 3, as I mentioned, that we have developed some context-aware image identification module. So context plays a very major role, and with the help of the context window of 3, we are getting an accuracy of 88.34% and F1 score of 88.24%. And also you can see that the results. So basically, disease diagnosis rate, success rate, dialogue length, average matching rate 2, and the dialogue and disease classification accuracy. So we are getting around 48.90 accuracy, and also average matching rate of 10.12, average matching rate 2 of 31.54. So there is an improvement over the unimodal baselines and of the state-of-the-art model. So the multimodality not only helps in improving the accuracy, but also helps in satisfaction. Hello, any question? So humans, we have also done a manual evaluation, and it has been shown that if suppose when that users, when the human can express the when the human is can express the symptoms through images, sometimes they are more satisfied. So there is a positive correlation between the diagnosis success rate and the dialogue length. And yes, dialogue context basically helps in proper identification of the symptom names from the images. So indeed, context helps in identification of symptoms from the images. And this multimodality basically helps, gives users more choices, because now the users can express themselves not only through text but also through the images. So now let me quickly discuss about our next work. So basically, basically here we have developed a motivational chatbot. So we developed a data set for the motivational dialogue systems, a large scale data set for the motivational dialogue system, and application of natural language generation to the mental health. So basically, we developed a data set for the motivational dialogue system, and then we also developed a, the chatbot for the mental health. So that the motivation is very clear, that that many people are suffering from many mental disorders, especially during the COVID-19 timing, when there was a complete lockdown. Because of the no physical activity, or because of no interactions, many people were suffering from the some mental disorders, and the depression is one of them. So depression disorder is a widespread and serious medical illness causing humans worldwide. So if there is a survey by the WHO, World Health Organization, which estimates more than 300 million people worldwide are affected by the depression, and it will keep on increasing. And there are many students who are also suffering from depression. So when someone, and there is a stigma, there is a social stigma that even though we are suffering from some depression or some mental illness, we do not want to visit a doctor, because there is a stigma in the society that if you are visiting a psychiatrist, then people will tell you that you are a mad person. So basically, the poor access and the stigma and the discrimination likely limit the clinical care to only 14% of those affected. So 45% of the world's population lives in a country with less than one clinical psychiatrist per 1 lakh mentally ill patients. So basically, that the motivation is very clear, that the global initiatives to reduce clinical depression are survey-based methods using phone or online questionnaires to identify depression. So, there are some online questionnaires, and by answering those questionnaires, the psychiatrist can easily identify basically the mental illness, like the severity of the mental illness. So mental health professionals are very much limited, and that this is also the ratio is very alarming. The number of mental patients and the mental health professionals is very alarming. And lack of early informedness for the MHPs leads to poor decision making, resulting in late intervention, causing deterioration in the quality of life. So can we develop a AI-based assistant which can help, which can act as a fast point of contact? So if suppose some person is suffering from some mental illness, then this this chatbot or the virtual assistant can act as the first point of contact, and then it can basically simply try to motivate the user. So its task basically it will be a shoulder to cry on. It will work as a friend, because whenever we are suffering from some depression, we need a friend who can simply listen to our problem, and only a shoulder to cry on. So basically this AI, this assistant will work as a as a basically this kind of motivational chatbot, which will try to simply motivate the user. So when we started working in this particular domain, we identified that there is no such dataset existing. So we created a large-scale dataset called the Motive, consisting of dyadic conversations between depressed and the despondent users and the virtual assistant. So the VA's effort is directed towards comforting and allowing the users to share and express their thoughts, moods, feelings, emotions, struggles, and the worries. So the virtual assistant should impart optimism, hope, motivation, which are identified as crucial affective factors to uplift the spirit of the users in distress. The virtual assistant should be competent and proficient enough to give user a natural human-like experience by responding empathically and affirmatively. So basically, we have this agent we have developed. First, we developed a data set. So basically, when we started working in this particular area, we identified that there is no such data set existing. So my PhD student Tulika Shaha, who is now a faculty in the University of Liverpool, UK. So she basically started this particular research. She was very much motivated to do something in the field of mental health. So that we crawled data many websites like some SAM, BHA, Ask a Patient, Daily Strength, WBMD, Ginger, Psychocentral, Health Rhythm. So there are many such websites. So we basically, somehow identify these websites, and then we crawl some data. And these are the websites where, a patient can anonymously register in these websites, and there are many such users who are suffering from some mental disorders, and then they can simply discuss amongst themselves. Like simply, if I am a mental patient, then maybe I can register anonymously without revealing my name or the gender or the age in this particular website, and then I can ask any question, and there are many other support seekers, and they can basically provide some answers. So we took permission from one of these websites, Psychocentral, and then we crawl some data from the Psychocentral. But the Psychocentral, basically, the Psychocentral is an online web-based platform for anonymous users to share their state of mind, feeling, and worries, and seek help and advice from other users having similar experience in terms of mood, difficulties, and the grievances. So we crawl some data from the Psychocentrals, around 5.5k number of the conversations, but these conversations are of multi-party, because one user has asked a question and there are multiple support seekers who can provide answer to the particular question. So, next we took help of a doctor in AIMS Patna. There is a doctor, Dr. Pankaj Kumar. So we took help of him, and with his help, basically, we basically converted these multi-party conversations into dyadic conversations. Because for our purpose, we need basically a doctor and a patient. We need this kind of conversations. So we basically he provided us some annotation guidelines. And then we employed some annotators who are graduate in English linguistics, and they are very good in English, and they basically manually created the dyadic conversations from these multi-party conversations. And there are some extra guidelines that are also followed. So the annotators were asked to create a turn-by-turn exchange of dialogues between the user and the VA from the responses of the poster and the commenter, and make maximum uses of responses from the source conversation to create a dialogue. And the VA cannot impart any medical advice. So basically, we remove all the drug names from the conversations, and the VA cannot impart any negative utterances. Utter any negative utterance. So all the negative utterances are also, are basically also discarded from this data set. So this is an example of a data set, like, JNCAT is saying, I am really struggling to take more sleeping pills and just pass out. I want to not wake up for a week. I want to take the easy way out and just sleep away. He is saying that's not you talking, Jane. It's the depression. So, JNCAT is not the original name. JNCAT is a symbolic name. So it's the depression. Give yourself some TLC. Do something you love, like long bath with a glass of wine. Go online and play some mind numbering games. Retail therapy. Remember the butterfly effect. You are here for a reason that you are not allowed to know about. Hugs and keep venting. So the Jenkat is saying, I double my dose to sleep, but I am still awake and typing fine. He is saying, take a little nap. Lie down for 10 minutes. Shut up your computer now. It's the best thing for you. You won't be able to sleep unless you lie in the dark. Give it a try. Jenkat is saying, tired sleeping, and then my mom tells me we have to go. So I am out and about. I feel fine, maybe a little flowy and light. Tell your mom about the pills so she can keep an eye on you. And please don't do this again. I worry for you. Now Jenkins is saying, I won't tell mom because she will take them away and won't let me take anymore. And I can't just stop suddenly. I will wait for my doctor and tell him what's been going on. So with the Bhavachal assistant, it's very easy to go for from 2 to 3 and to 4. The recommended doses is there for a reason. And unless you are a medical professional, you should follow what they say. So then basically there are such conversations, and finally the virtual assistant is saying you need to take responsibility for your thoughts, feelings and behavior. It is not our fault we have this disease. We are not to blame, but we have to be responsible. Own it, take care of yourself. So in our dataset, there are some 4,000 uttered dialogues and 14,000 utterances. Average number of utterance per dialogue is 3.70. Average number of utterance per dialogue is 47. Maximum user utterance length is 3321. Maximum V utterance length is 961. Number of unique users are 1000 and number of unique words are 59,363. So basically now our task is to basically automatically generate the virtual assistant response. So given the user's utterances and given the context, the task is to automatically generate the textual response. So basically we aim to solve the task of textual response generation between a user and the VA involved in the dialogue along with the conversational history. So there is a user response, there is a conversational history, and now we have to generate a response for the VA. So we developed two models, sequence-to-sequence model and the HRED model, hierarchical reinforcement learning-based model. So, these are the two existing models. So sequence-to-sequence model it can be also used, and the hierarchical reinforcement learning-based model can also be used. So we are using different loss functions, cosine triplet loss, negative log likelihood loss, and we are taking a combination of these two losses. And that way we are basically trying to build a virtual assistant which is motivational type. And these are some results we compared with some baselines, and we are getting some blue basically blue score basically matches. There is an actual response and the virtual assistant is generating some response. So what is the similarity between these two responses? That is captured by the blue score, and we are getting not very good blue score, but our generated responses are very good. Like here you can say an example, like suppose user is saying, I am so depressed and overwhelmed with emotion that it hurts, I can't breathe. So the ground truth is very long, like I am sorry you are feeling this way, just know it does not last forever. When you feel this way, just hold on to that and look to the future when it would be over rather than live in the moment. Just remember it won't last forever, though it may feel that way, take care. Now our proposed model is generating this. I am sorry you are feeling this way. When you feel depressed, think about the future. Nothing lasts forever, take care. So this is the these are the works. So I think time is up. So I should stop and take some questions. So if you have any question, please feel free to ask.
Ma'am, the blue score is 0.234. So how we can improve the blue score?
Yeah. So this depends on the data set only. So basically, you know that if we can increase the amount of data set, because you know data set creation is very challenging. You know, for this mental health domain, getting good quality of data is very difficult. As I mentioned that we crawl the data from the psychocentral, and from the psychocentral we crawl the data, and now we are using this data for building this particular model. So yes, we are creating more data. So I think if we can increase the amount of data, then we can build some better models. So that is the basically, you know, this deep learning models are heavily data dependent. Data is the fuel, or data is the, you know, the oil basically. So if you can increase the amount of data, quality of data can also be improved, and then according to the model can also be improved.
But ma'am, Blue Score, as per my understanding, is for machine translation, the quality of machine translation. So
no, so here also it is a, yeah, here it is a generation task. So basically, you know that our conversational agent is generating a response, and you already have the gold standard data. No, like here you have. Can you see my? Let me show my screen again. So basically, you know, already you have the gold standard data. Like machine translation, you have the gold standard translation. Similarly, here actual response is already known. Like here you can see this example. So here, if this is the if this is the user's utterance, then this ground truth is the actual response that is expected. Okay, and now we are getting this HRED2 plus ARL. This is we are getting. So basically, now we are seeing the similarity between these two. So Blue Score basically captures the similarity between the ground truth and the our predicted response. So it is string matching. In machine translation also, this is string matching. You have the ground truth translation, and your system is generating a translation, and then we used to do a string matching. And here also it is a natural language generation task. So your system is generating a response, and you know there is a ground truth response. So you are making a similarity matching.
Okay, ma'am. If ma'am we changes the language, then can it work? For example, if it is Hindi or some other language, I mean, for that, what we have to do?
For that you have to again train the model. You have to again train the model. So basically, Hindi data we didn't get. So there is no such, you know, website from where we can get some Hindi data. But what we can do is that this English data can be manually translated into Hindi. Yes, so basically, if you want to develop something in Hindi, then you have to first translate the data into Hindi. So basically, you know, you have to retrain the model in Hindi, because the vocabulary would be different, no? So basically, you know, English is having his own set of vocabulary. So Hindi will also have its own set of vocabulary. So as the vocabulary will be different, so you need to retrain the model again.
Ma'am, other, for example, machine learning that you have used, I think, sequence to sequence model. So what are the other models which we can apply for this task?
So nowadays, you know, this GPT or the chat GPT or this, you know, all the, you know, there is a BRT BART, there is a T5. These are all transformer based models. So you can easily utilize these transformer based models for this task. You can fine tune them. No need to train it again, but some last few layers you can fine tune with the help of this data.
And what is the advantage of using this sequence to sequence model? I mean, here in this.
So it basically captures the context. Like, you know, based on the context, it basically generates a send. It's a very, you know, the base, like a very simple model. So sequence model is the base model of machine translation, and also the basic model of the natural language generation. So it sees the context based on the previous words. Already, suppose some words are already generated. So based on the previous words, it will try to generate the next word.
Okay, thank you, ma'am. And ma'am, I just like to ask what IIT Patna, there is one department called the Center of Endangered Language. So what is their, I mean, job?
I think they are working, that is basically linguistic department. It's not, it's with the humanities department. So they are doing some research on these endangered languages.
But they are also doing some kind of, you know, the machine translation. I recently visited there. So they are also actually, I have also presented one paper from Angika to English. So, I mean, it was the local language of Bihar. So that was for NMT, neural machine translation, and where I have also used this sequence to sequence and other models.
Very good, very
so
good.
That is why I'm just asking what the Blue Score and all, because I was also getting a low Blue Score there.
Yeah, it's very, you do some human evaluation, okay? So sometimes blue score can be low, but maybe if you will do the human evaluation, you can judge the readability or the meaning, whether the meaning is preserved or not, readability aspect, so adequacy and the fluency. So you can do a manual evaluation also. Like blue score is not a good measure also. Sometimes maybe the same thing can be expressed in different ways. That's why
Yeah.
human evaluation plays a very major role in machine translation in generation.
Yeah. Okay. Thank you so much, ma'am. Thank you.
Yeah.
Is there any question? Okay, no question. Thank you, madam, for providing us with your precious time and knowledge. Your take on virtual assistants was quite insightful and detailed. The visual aids were very helpful in understanding the process of end-to-end dialogue system. You made us aware of the opportunity for automatic disease diagnosis in our society healthcare system, and your explanation of its working was very comprehensive. Your proposed hierarchical reinforcement learning based model and symptoms association investigation system was very interesting. The addition of the case studies in your explanation definitely made it easy to understand them, and I am sure the participants gained enough knowledge from your extensive yet clearly presented project details. Once again, thank you, madam, for giving us an opportunity to learn from you. Thank you, madam.
Yeah, thank you, Dr. Dilip. Thanks a lot. Yeah.
Thank you, ma'am.
Yeah, bye bye.
So by tomorrow, session will started from 2 p.m. to 5:50. So okay, today actually inaugural session was there, so we conducted from 11 to 1. But by tomorrow, it is not going to be conducted. It is going to be conducted by only from 2 to 5:50. Only 3 sessions will be there. So thank you everyone. Join by tomorrow from 1:50. Okay, thank you. You all very good. Thank you.
Okay, sir.
Thank
Thank
you,
you,
sir.
sir.
Thank you. Thank you.